There's disassembly as well, but typically people don't really need a lot of training on disassembly. They're pretty good at taking stuff apart. It's the knowing if it's good or bad, and reassembly that tends to be a bit of the more challenging one. So disassembly's in here. The main thing with disassembly is just keeping your stuff organized, keeping your parts where you know where they came from, etc. Right. So jumping right in. Some of the inspections we'll be doing are like warpage, something that some of you have done, but some of you have not done yet. So I want to point something out on the screen too. If you look over here, this precision measuring tool has a bottom edge right there that's worth, like Roberto was saying, a couple $100 is how precisely machined that is. So if you're using a straight edge, it's an actual straight edge. It's not like just some random piece of steel that looks like it could be straight. This is something that's been precisely machined. And also, this upper edge right here is not straight enough. A lot of times it has one smooth, shiny, really nice edge, and that's the edge we should be using. And then going for the feeler gauges here. So typically on the stuff we work on, it really won't even take one feeler gauge. But like in this example, they're saying the maximum warpage is 0.07 millimeters. So if that's true, typically what you do, bust out a 0.07 millimeter feeler gauge, which might be something more along, a 1.5 thousandths, and they do make a 1.5 thousandths feeler gauge, or even maybe potentially up to two. And then we're going to try to slide that in at various points. And if it doesn't slide in, that means it doesn't have the 0.07 millimeters of warpage. So that's good. But then we're going to also do that in different directions, right? Like at the top, at the bottom, diagonally, um, going from the intake to the exhaust side. Basically the same thing that we talked about on the head, except in this case, we're doing it on the block. Is it likely to warp a block? Not really, but it's possible, especially if you have, let's say, a blown head gasket between two cylinders. The exhaust gases or the combustion gases are going to be trying to go back and forth between the head gasket, and the block. And it has worn some of them away there. So it's not really likely, but it's something that it calls for, and it's something that if you don't do it, it ends up being a problem. Like you put a head gasket on, or you rebuild this engine, then it has an issue. And if you didn't measure this, it's kind of your fault, even though it's not real likely to have happened. The heads warp um, before the block typically, and the head gasket fails before the heads warp. So it would have to be kind of an extreme case, right? So continuing, another thing that you'll run into, if you look at this cylinder, this is like a really good, basically visual representation of what happens. Your piston goes up and down, but it doesn't go all the way down. So if you look right here, you've got basically a fresh, brand new cylinder bore that's never really had pistons run up and down it. So it's pretty nice. But then over here, you see where it gets a little bit bigger. That's where the rings have worn into there a little bit. So when we go to do our measurements, I just want to point out that the bottom, if you go down beneath where the rings have gone, that's going to be your board measurement. So that's like a little tip. Like yesterday, Daniel, not this Daniel, the other Daniel, we were looking at his block that has some unknown number of miles on it, that has a fresh rebuild. And we are trying to determine if he has oversized pistons or not. And he was getting measurements well above what the stock piston size was, but only by about 3 thousandths of an inch. And they don't make 3 thousandths of an inch oversized pistons. So I'm quite sure, I haven't followed up with him yet, that if he were to take the dial bore gauge or the T gauges and measure down here, he'd find this is the stock bore. And then if he were to measure up here, he'd find this is a little bit bigger than the stock bore. But if you were to measure up near the top, like let's say a ½ inch down, you're probably going to find the most wear, because when the pistons coming up, that's when it's got the most compression. So it tends to try to, move around, and that's going to put some more axial and thrust wear on the cylinder. And so he may find 3/1000ths of an inch more wear here. Now, we talked about that once. And there was a term for that when it's worn more towards the top and less towards the bottom. Let me remember. All right, I'll give it to you. That's taper. So if the cylinder is tapered, that's telling you that it's got the amount of wear on there. So if he has 3/1000ths more on the top than he does the bottom, that has 3/1000ths taper. But here's a little detail we haven't discussed. At the very, 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 very top, the rings don't go there. So that's what it's showing here. You may have a ridge formed by carbon deposits, but also you may have a ridge left by the rings, because think about it, the rings can't go all the way to the top or they'd start to actually pop out of the cylinder. If you guys have done your overhaul, you realize that's true. They do tend to pop out. They're kind of hard to get back in. That's the whole reason we have a piston ring compressor, right? So these things to watch for. Additionally, on the disassembly, something that we mentioned at one point is if you're gonna get them out and there's a nasty ridge, this is not supposed to be for cutting the metal. This is really for cutting the carbon off. So you could actually put the ridge reamer on there and ream the ridge off so you can get the pistons out. And that's just mainly so you don't damage the rings, which is a little silly because you're probably going to replace the rings anyway, but it can be harsh on the cylinder. All right, but be forewarned, the ridge reamer is a pretty aggressive cutter, so it will cut that cylinder liner if you're not really careful. All right, and then when we're doing our inspections, a lot of the inspections we do are visual. So a lot of the inspections are measuring too, probably more of them. But on a visual inspection, you got to have a lot of attention to detail. So if you're looking at this cylinder wall here, this has a lot of scuffing. Scuffing is where it's just generally kind of like scuffed, like shiny. The piston's been going up and down in there for quite a while. And then there's a bit of a score there. That there's a score right there. That is more like something got drug past the ring. So there was some sort of debris. Exactly what the debris was, I don't know. Maybe dirt. If you think of dirt as a big granite, jagged, nasty boulder, but then you make it microscopic, that'd be pretty accurate. So this could have been dirt. It's tough to say, but we know that something got drugged through there. We know that this would need to be addressed. And then additionally, this one is kind of between scuffing and scoring, but down here is definitely scoring. And if you look at this one, these scores go past the bottom of the ring travel. So if you look, you can see the change in color. The rings have gone down to this point. The rings don't go in where it's a little more golden looking, a little more brown. So this is something that's been getting ripped back and forth like by the piston skirt. So the piston skirt goes down that low. You'd have to really look at that piston, and most likely you're going to find the piston's damaged as well. So if something gets between those two and the piston gets scored, it's going to also score the cylinder. And then obviously you're going to have to address both. If you clean this cylinder all up and you put the same piston in there, it's obviously going to cause the same damage. Now let's speak very practically about why this is a problem. The scuffing actually isn't that big of a deal. That's just a sign of mileage. But if you see there's cross hatching here, you can see pretty well. When the scuffing occurs, it basically wears down the tops of the cross hatching, and it makes it so the cross hatching is essentially erased. Like you've run an eraser over it and just made it disappear. If the cross hatching is gone, why is that an issue? And when you think about it, the cross hatching is good for the rings, to wear. And Mitchell, go ahead. What's your thoughts?
So is the cross hatching on a on the cylinder sort of like how there's cross hatching on a brake rotor?
A little bit, and that's why I mentioned like the piston rings would appreciate cross hatching. I think it helps to kind of break them in, but it's much more important than that. Like the cross hatching on a rotor is a lot of times done from the factory just to get like a non-directional finish, and sometimes get work out a really tiny minor defect. But on this, it's actually much more important. So if you look at the X's and let's say, they're at the correct angle, every X you have, like this, like if you see my hands, that's a point where oil will reside. So when the ring goes by, that's just a little reservoir in a way for the oil to lubricate the rings on the way up and down. Everywhere the cross hatching has disappeared, that's glazed. That's no longer going to have any oil on it, which means your rings are being drug across that essentially dry. So the more glazed it gets, the more friction there is, which means the more glazed it gets, which means there's more friction, which means there's more wearing and glazing. And so once you lose the cross hatching, it's kind of a matter of time until that cylinder gets more and more wear. So if you've got a cylinder with that 3 thousandths of wear, that actually would have started with a glazing, eliminating the cross hatching. So there's looking at it, that there's more wear here. It's going to be a little bit bigger there. How much? Well, like the next slide we talk about, we have to do a lot of measurement. Let's back up to the visual. This visual inspection could give you a clue as to what might have happened. So let's say that you're doing a tear down and you inspect this and find this, you may have to take a look at like, well, why is, especially if it's low miles, why is there scoring? What got into the cylinder? If you think it's dirt, maybe you really need to look the air box over and the intake ducting and tubing. Maybe there's a loose clamp. Maybe the air filter's got a hole in it. Maybe, right? So we're using these as clues. But additionally, as you're doing these overhauls, you need to really consider what would this cause? So I just described what could cause it, dirt intrusion. But what would this cause would be more like if these are scores and they're kind of deep, you're going to have oil left behind in the actual scoring. And then the piston's going to, come down and leave oil up here somewhere. It's not going to, the piston oil control rings, the lowest ring on the piston assembly is not going to scrape the oil clean, which means the oil is going to be left in the groove in the score, especially if it's towards the top. And then when we get a combustion stroke and we burn the hydrocarbons of the fuel, that flame isn't going to discriminate. It's going to see that oil right there and be like, yep, I'm burning that oil too. Now you got oil consumption, right? So if you had a vehicle with oil consumption, you tore it down and you found this, well, you just found at least one of the sources of the oil consumption. So let's put it in perspective. If a customer vehicle's dropped off and their main concern is oil consumption, and you're looking everywhere and you're checking the PCV system and you're doing compression tests. And by the way, this may, if it's bad enough, cause your compression test reading to be low in that particular cylinder, right? So they tie together. And then, let's say that this is a job that's kind of low miles under warranty. TAS may very well say, hey, we want you to do a teardown and find out what's wrong with that. They don't want you to do a teardown to prepare for machining the block, although an independent shop or a machine shop or something might. At the dealer under warranty, you're not going to really machine this. In fact, 90% of these Toyota engines are not machinable anyway because it's the thin spiny liner, meaning it's aluminum with a small layer of hardened iron basically cast into the mold. So you can't machine it, but they may want you to get down to the bottom of why is this consuming oil? Maybe there's a pattern. Maybe they've seen 10 of them across the country in that month, and they want you to basically determine it. Is there a machining issue? Is there like a quality control issue on how they're being cleaned? But in this case, it's scoring on the cylinder wall, which maybe they want pictures, maybe they want to document it, and maybe they want to see if there's a pattern. Okay, so you may be asked to go a little deeper and find something like that, right? So the visual inspection is going to tell you a lot. If you want to know how much it's worn, that's when you get more into the measuring. So for example, using either one of these tools, and we got some videos on the two, but I'll discuss them anyway. We can tell, is the cylinder out around. So for example, the thrust direction, I could show you a little bit better in here. If you look down here, here's the crank. That piston is being kind of thrusted in this direction, right? So if you picture the piston, here's my hand, the piston's going up and coming down, right? A lot of this, and this would be the thrust direction. What the piston doesn't do is a whole lot of this. It does this, so this direction to this direction is thrust. Right. This one is thrust, by the way. That would be where you'd expect the wear in the thrust direction. The piston's being moved around more in that direction. However, right, this is the thrust direction. This is the axial direction. So if there's a difference between the two, you've got what we call out around, right? We talked about that. But and that should be something, a little bit of review from actually unit 1. However, we want to add to that. If you've got thrust direction, you'd mostly anticipate that to happen with miles. So if you got miles and you got thrust wear, that's normal. However, if you have axial direction wear, that's entirely different. You really shouldn't have axial wear. Now, if anybody's already like really thinking ahead and really kind of got this dialed, you may already start to think about what could cause the axial wear. Roberto, I see your hand. Go ahead.
So when we were measuring the boy yesterday,
Uh-huh.
the top of it was at like 3.61, and then the rest of it was at like 4.41. How is it that the top could be at 3, and then the middle at like 4, and the bottom at 4 point something too?
It's the taper.
Yeah, I'm listening to your numbers. I don't think your numbers totally make sense, so I'm gonna improvise on some numbers, okay? Let's just say we're working on Toyota, so that's generally in millimeters, but ASE is gonna focus on thousandths of an inch, so I'm gonna switch it over to American units of measure. Let's say that at B you got a 4.000 bore. And then at A, you got a 4.003 bore. Your question of how can that happen? Well, that's why we're measuring it. Your engine had been run. Your engine was, used in service. How many miles? We don't really know, but there is wear. So that would be an exact example of taper. Mitchell's right on that. Um, if you have a tighter measurement on the bottom and then a larger measurement on the top, that's pretty typical wear. Now we've also seen where the service manual will call for a bottom measurement, and you may actually find the bottom measurement may be the smallest, and then B might be the same as the bottom, or it might be a little bit bigger, and then A lot of times will be larger. But that's all what we're measuring for defects. And then on like some of the older, like Daniel was using it's the TSRM, it's the pre-TIS book written service manual, and they actually gave a pretty interesting spec. It was talking about you're measuring differences, but it gave you a specific formula of basically including your honing process. So when you go to hone a cylinder in the machining, like let's say you're rebuilding it, we're going to hone it. The hone doesn't necessarily get it perfectly true. So it was actually giving up to 2 thousandths of an inch. No, I'm sorry, that's not. Yeah, I think it was. It was like potentially up to 2 thousandths of an inch for honing imperfection, but it wanted you to try to bring that down. So if you had, let's say, a total taper of maybe 3 thousandths, they were kind of showing like that could be potentially 2,000 of that could be honing allowance, right? So you may actually have only got 1,000 of that taper from wear and tear per se. So it was kind of interesting to see it like that. I am quite sure that the current machining processes are going to be much tighter than 2,000s. 2,000 is kind of a lot, but remember that was a service manual for a 1987 or something. So things were a little different back in the day. But those measuring differences from A to B, that's your taper. In this direction, axial to thrust, that's your out of round. And so we're gonna measure both of those, but I still want to make my point on the axial wear. If you have a cylinder with axial wear and you're like way ahead on this, you might actually already know what could cause that. Say we got axial wear. All right. Now this is where I'm going to bring up something else. Look at this, one of these first steps on this worksheet here. We got a dial indicator on the connecting rod, and we're moving the connecting rod back and forth. We're basically checking for connecting rod thrust, or almost kind of like end play. If this connecting rod is loose and walking back and forth in this direction, look at where the crankshaft is going. It's going along the line on the same axis of the crankshaft. That would cause our axial wear. So let's say it's cylinder number one only. We'd be down here like, whoa, cylinder number one's got a whole bunch of axial wear, and now it is out of spec on out of round. So we know we need to replace or machine the block. Well, you got to do this inspection. That's the whole reason you're doing this inspection. So if you're following the worksheet in the packet, you're doing these things, but you might not exactly know why you're doing them. And I'm trying to link those together. If this connecting rod has too much axial movement, it will cause excessive axial wear, at which point you'll have to address this axial movement. And actually the process for addressing this axial movement would be begin by replacing the connecting rod and then remeasure. And if you put a new connecting rod in and you remeasure and it's good, then you're good to go. You can put a piston on that connecting rod and, continue the overhaul. But if you put a new connecting rod on that number one and it's still no good, that leaves actually the crankshaft must be kind of worn out and it's still allowing too much thrust movement. Well, then you need to replace the crankshaft, right? So when we're doing this with regard to not only ASE, but also your write-ups, because we're not generally going to be doing machine work, you got to be very thorough. So if you have a measurement that's out of spec, for example, the axial measurement for out of round on cylinder number one, you would need to know where you need to go look to find the cause of that axial wear that's excessive as the effect, right? So a lot of it's tying these two. Now, the way that the ASE could ask you to demonstrate that understanding, they may say, two technicians are discussing engine overhaul, and cylinder number one has excessive axial wear. Technician A says that cylinder needs to be bored honed and the piston replaced with oversized, as well as all four cylinders. Technician B says it's possible, or a worn thrust bearing could be the root cause, right? So now you have to interpret, is what Tech A saying correct? Or Tech B, or neither, or both? So if Tech A just said it's excessive, right? Because they might just give you the numbers. If Tech A says it's excessive, I agree, it's excessive, cool. But that doesn't really address what might have caused it. Now, B, I'm trying to trick you a little bit. B said a thrust bearing, and I want to pause for a moment because you guys have done some crankshaft work. The thrust bearing controls the thrust of what? One connecting rod, or not one connecting rod? It controls it for the entire crankshaft. So if we had a crankshaft bearing that was worn, a crankshaft thrust bearing that was worn, and the entire crankshaft was thrusting out of spec, which cylinders would be affected? And
Can you repeat that?
if we have all four cylinders having excessive thrust wear, I just answered my own question. Okay. But I'm going to think you might have forgotten. So if we were to go ahead and measure that crankshaft thrust and the entire crankshaft had too much thrust, which cylinders would be affected by that?
Pretty
All
much
four?
as you said, all
Yeah,
of them.
so now you were just remembering what I said. Yeah, that's right. So B was saying, oh yeah, it could be bad thrust bearings. But what I was trying to show you there is a bad thrust bearing would make the whole crankshaft move. All cylinders would be affected. Whereas if it's just one cylinder, that's why we're doing this measurement in the first place. If one cylinder is affected, we're really looking at the thrust measurement for the one connecting rod on that particular cylinder. They both are issues, by the way, but a thrust bearing causes all four cylinders or six or eight or whatever, whereas a connecting rod wear would cause just one. Okay, so you got to be able to link those two in what they cause. So with that being said, I think you guys kind of get the point, even though I accidentally gave you the answer. When we're going ahead to measure these cylinders, there's two options in the T gauge or the telescoping gauge. You know, when we're trying to do that measurement, if we're crooked right here, that measurement's going to be larger. So a lot of times people will come and say, hey, I got all these crazy measurements. And it's just quite honestly, they're not proficient in precision measurement yet. Okay, so that takes practice. That takes a little bit of studying in the book and a lot of practice in the lab and in the shop. So when you're using these T gauges, if you got a number that's high, there's a good chance you had your T gauge crooked. So you remember one of the processes that we demonstrate is, you know, using that T gauge and getting it where you think, and then sweeping it. You're gonna move it like this, and it should be loose, and it should just barely drag the surface at one point and then go loose. That's how you know you're perfectly square in the cylinder. It's tough to get it square. It's a pain in the butt. And this is just prone for error. You're taking it out, you're assuming it hasn't slipped, you're putting the micrometer on it, you might compress it a little with the micrometer. They're just not, you know, they're just not the best way to do it. If you want to really do it nice, you do the dial bore gauge. The dial bore gauge takes more work and more setup, and that's why I did a demo video on it. And you know, it's harder to understand it, but if you get to the point where you can use it and understand it, this tool is going to be much more precise. You can set the base number, run down to the bottom, make sure it's the base number, 4.000, whatever. Flip it 90 degrees, check it again, 4.000. There's no taper, there's no add around, right? Because you just moved it. Bring it up, middle of the cylinder, 4.000, 4.000. Bring it up to the top, maybe 4.001. Now you know you got about a thousandths taper. And then you could flip it the other way. Maybe you say you got a 4.002. That would mean that you got about a thousandths add around right off the bat. Is it great for just jamming it in the cylinder and then being like, oh, this is the measurement? No, because it doesn't really give you the measurement. You basically set it up at the base measurement, and then you can move it all around to see how tapered it is and how out around it is. And very quickly you can tell if it's in spec or out of spec, right? So the cylinder bore gauge is the preferred tool. You still have to do the rocking though, but as you rock it, the smallest measurement is where it's square. So the smallest measurement you got on here, it's good. So it goes bigger, and as you rock it, smaller, and then bigger, bigger. So you'd really just note the smallest number. That's how you know you're perfectly square. Right? And you can roll right through those. And then again, considering the inspection, we're obviously looking for scoring on the piston, not just the cylinder. This has a broken ringland. So any of these visual inspection items, you know, that needs to be, we need to figure out why did it fail and what did it cause when it failed, and is that matching up with what the customer concern is, right? And then when we talk about pistons here, this is actually something that's commonly on the ASE. The piston should have a larger diameter in one area than the other. And the reason why, these are concentrically ground, which means they're not round. They're not round, and they're not supposed to be round, because if you were to go ahead and put them in the cylinder round, and then you were to actually notice, like right here, there's a big cavity. There's not that much material here. But if you would turn it the other way, because this has the pin boss, it's got all the machine work for the pin, there's actually a lot more material in the axial direction and a lot less in the thrust. It would, if you thought about it, if you heated that piston up, it's not going to expand at a perfect rate of a circle, right? Aluminum expands with heat, but if the more aluminum you have, the more it's going to expand. So in these spaces right here, it's not going to expand that much in the thrust direction. It's going to expand more in the axial direction because aluminum heats up at a percentage, right? So if aluminum expands 4% and you have more of it, you have more expansion. So it's going to expand more in the axial direction, which means the axial direction has to be actually a little loose. A little loose because when it starts up, it's going to expand, and we want the final end product when it's warm at full operating temperature. We want that to be round. We don't really want the cold piston to be round because it's only going to be cold for 30 seconds or so. We really want the hot piston to be round. So there's some measurements that they're going to call out. Just know a lot of times this measurement's going to be smaller because we want a little bit. A lot of times we'll want a little bit of taper right here. We don't really need a ton of sealing right here. We need the skirt to guide the piston. Where we need our sealing is more like up here. So the largest measurement is going to generally be up more near this ringland here. It's going to be our larger measurement up here. And if you really must know, it's actually going to be in line with the pin. That's where we're going to see it. Basically, where the most metal is, where the most aluminum is, that's where we're going to have our, sorry, in the direction that we're looking at right now, in the way that the least metal is for expansion, that's going to be the largest. But when it's up to temperature, it's all going to end up round. So in this direction right here, right where the mouse is, that's going to be our largest measurement. Okay, I'm trying to keep it straight, right around these ringlands. Right. And then technically in this direction, along with the pin, that's going to be just a little bit smaller because there's more material. Okay. And then how do we know if it's in spec or not? Well, like anything, it's going to call for, a minimum and a maximum. And if it's within the minimum and maximum, then we're okay. Like, so for this example, it's actually talking about, why don't you go ahead and measure from 15 millimeters from the bottom? And that's are going to be the piston measurement we're going to go with. But then it's going to have us go over to the cylinder and measure the cylinder. Now, those should be different numbers. So if we were to get numbers, something along the lines of, let's just say, we'll make it inches again, because that's more ASE related. Let me see. Yeah, I was going to get the pen up, but I can't. So you're going to have to listen to my numbers. So if we were to go to the oh, it did work. Let's say that we were to get 3.995 inches, and then we were to go ahead and measure this, and we were to get a 4.000. We could do the math and we can find out how much clearance there is. So that's what they call the piston oil clearance. And there's a little bit more we could actually interpret from that, by the way, but right off the bat, how much clearance should there be? Or how much clearance is there in this measurement based on that math?
5,000.
Exactly. So if we got 5/1000ths of an inch of clearance, we can go ahead and look that up in the service manual and say, is 5/1000ths good or is 5/1000ths bad? And 5,000 is probably good, but again, that's why we're doing the measurement. So if you wanted to measure piston to cylinder wall clearance, you're not doing you're not sliding a feeler gauge in here. That's not a real measurement. You're going to actually go ahead and measure. We're going to make this about health class now. You're going to measure the male part and you measure the female part, and then you can do the math to calculate how much clearance there is between the two. Okay, that's as much as I'm gonna say. I'm gonna move on now. We're just gonna leave that right there. We're gonna click next, just move on. Additionally, we're looking at these bearings, of course. So we're looking at those bearing surfaces. This one is all scored and galled. That bearing's no good. We could put a bearing in it, but we also need to look at the mating surface. Here we go, we're back on health. But it's true, the mating surface, that's just means that's where they're contacting, they're rubbing together. So the mating surface is the going to be, like in this case, the rod journal of the crankshaft. you need to inspect the bearing. You need to keep track of where the bearing came from. You need to look at it. If you find a defect, you need to then look at what the mating surface is. In this case, the rod journal. You'd be like, oh, well, this is torn up, and also this is torn up. That would need attention. So let's say that we have that type of scoring. The crankshaft is pretty hard, the bearing's pretty soft. This scoring and this scoring means that this bearing is going to get shredded. It's going to be torn away. That bearing is essentially like a soft material that's going to act as a sacrificial lamb to save the crankshaft. Okay, so the bearing is getting material pulled away, pulled away, pulled away. Some of that material is going to be copper, by the way. And there's a company that you can drain your oil out and put it in a little container and send it out, and they can do analysis. And if you have excessive copper in your oil, that's a major clue. Like, hey, you got a copper in the oil. Copper comes from the bearings. We know that you have a bearing that's starting to fail, right? So we could do the tear down and look at this. But if you don't want to pull the engine out, pull the engine all the way apart, you could actually take an oil sample. Blackstone Labs will tell you you got copper in the oil, and that's gonna pretty much tell you, hey, I at a minimum need an overhaul. At least stop driving it to maybe potentially save that crankshaft, right? But that's what we're doing when we're inspecting. This one, for example, this bearing is out of place. This bearing should not have a seam right there. That seam should be down here at the rod. This bearing is what we call spun. So this bearing backside is actually been spinning inside of the connecting rod, which means this bearing surface has started to friction weld to the crankshaft surface. And now the crankshaft surface is messed up, but also if the backside of that bearing has been spinning in the connecting rod, that connecting rod's going to be messed up too. So that is one of the examples where we may need an oversized bearing to address the connecting rod that would need to be reamed, and an undersized bearing to address the fact that we're now going to have to cut this crankshaft down. We're going to have to grind this crankshaft. How much? Well, to the next bearing size, assuming that's enough material removed to fix the defect, right? So we're measuring these types of things and visually looking, both measuring. Now, when we talk about how it's worn away, I want to jump back to here. If the cylinder is worn and the piston is worn, and we were supposed to have 5 thousandths clearance here, but now we have 20, that piston is going to be kind of loose in the bore, and that could make it rock around. And that's actually called piston slap. And piston slap could be normal, like 5 thousandths, 10 thousandths clearance. The pistons could slap with that small amount, but that would be when cold. And then after 20 or 30 seconds, if it goes away, that's a pretty good indication. Hey, that was piston slap, because the pistons are small when they're cold, and then when they get warmed up over 20 or 30 seconds, they fit a little tighter in the cylinder, and it takes away that kind of knocking noise. That could be normal piston slap. But if you have a piston that's worn and you have a cylinder that's worn, there's going to be excessive clearance. It could make kind of a clattery knock just due to piston slap, right? And then if you look at, let's say, if that bearing is worn, and the bearing clearance is supposed to be much tighter. If we're supposed to have about 1,000th oil clearance, maybe 1.5, maybe like 1,000th and a half, maybe even 2 thousandths, but probably not on anything modern. You're supposed to have about 1,000th of an inch. If that bearing wears, you can quickly end up with 30 thousandths of an inch. That means there's going to be looseness there. That's going to make a knock. That's actually your classic rod knock, is you end up with excessive oil clearance right here because the bearing is worn, and now you're rod knocking. Technically, a rod knock, a lot of people would say that's the death of an engine, and they may be right, but technically, if you got a rod knock and you caught it early and you yanked it apart, you may literally just need to clean this up and put a new bearing in. That's not expensive. It's a lot of work though. So the labor is the expensive part. But generally, people hear the rod knock and they're like, oh no, I got to drive it to work the rest of the month, and then I'll bring it into the shop. And by then, the crankshaft is worn down. The connecting rod's totally shot. It's maybe spun. Now you're looking at a crankshaft and a connecting rod and all new bearings, and then it is the death of the engine. Or they keep running it long enough where it completely friction welds, and it blows a rod out the side of the block. So, you know, it is the beginning of the death of an engine. But if you catch it early enough, it's actually not that big of a deal. Okay, so understanding that that would be where the noise would come from. It'd be the clearance. If your clearance is supposed to be tight, but your clearance ends up not tight, you know, that's where you get clack, clack, clack. You get more noise. All right, so continuing, similar to the cylinder, we can have problems with taper and without a round. So we're going to be measuring all these journals. This one again is like that rod journal. Actually, this one's the main. This is a rod, main, rod. So if we're measuring a main journal, we're going to not only measure it here, as you can see, we're going to measure it in two spots, here to here and here to here. And if we got a measurement of 2.000 and 1.990, that would indicate we have 10 thousandths of taper. How to get tapered? That's a good question. That's hard to say. Honestly, that kind of sounds like it's more a machining issue, but if you had a weird issue with the rod and the bearing and you ran it like a bajillion miles, maybe it could actually taper. But sometimes what we're really checking for is the machining quality of that crankshaft, right? Now, if you were to measure it more from this angle, right? From top to bottom and then side to side, if you were to put times on it, this is 12 to 6, and then you were to also measure it from 3 to 9, like kind of like this in this picture, right? Blue to blue, red to red, that's out of round. It's really the same as a cylinder, except we're not measuring the cylinder, we're actually measuring the crankshaft. We'd need to know there is a specification on maximum allowable taper and maximum allowable out of round, and they're very small, like basically nothing, but you can measure it. That, by the way, is also in the worksheet, and it has you do that a little bit lower. We're going to come back up to that plastic gauge. And PS, we were talking about the whole entire crankshaft. This is how you measure the whole crankshaft thrust. You see that dial indicator? That's checking the actual crankshaft thrust bearing, just FYI. And warpage, and we talked about cylinder wear, and we'll talk about it a little bit more, but here's your T gauge in action. Here's your thrust as A, and thrust is B and axial is A. There's your taper in three points. But then we jump into, there was a lot of piston measurements. Then we jump into more of the, there's your piston oil clearance, by the way. Everything we're talking about, you're going to have to do, or you've already done, but you didn't really understand it. Right. And then when we get down here, look at what we're measuring. Just what we said. This is going to be your taper, and this is going to be your out of round. And so it's going to have you measure those on all the journals. And actually, this is one way I found that's easier to do it, because basically your difference between A and C is going to be your out of round. And then your difference between A and B is your taper, and C and D is your taper. And you want to go with whichever's worst. So if you have 1/1000th taper from A to B, but you have 2/1000th taper from C to D, you have 2/1000th taper. You got to judge it as harshly as possible, right? And so that's all these measurements. That's kind of what this is walking you through. And that's both for rod and mains. Okay, so we continue. Okay, now we're going to go through how to go ahead and use some of these tools just as a bit of a review. So like a micrometer, this is how we're measuring the journals. How to read the micrometer, we had covered a couple different times, but if you guys need any review on that, we could do review. Another thing I'd like to point out is one of your required e-learnings is called precision measurement. Be a good idea to go through that one again. But this is us here measuring the external. So we're using a micrometer to measure like an external surface. There's actually an inside micrometer to measure inside surfaces. So now these are the tools to do the job. But you could also use a T gauge here, although less preferred. And you could also use a dial bore gauge, which is probably even more preferred than the micrometer. The micrometer is great, but it's a little harder to tell that you're square in the bore. The other little bit of a problem that I have with the micrometer is the micrometer is sitting on the bearing, and you're causing a defect on the bearing. So the micrometer is great on the old bearing that you're about to throw out, but I'm not sure I would put that micrometer through the new bearing. Once we do all of our measurements, we can determine, you know, our oil clearance. So if this is measuring 2000 and this is measuring 1997, you know, you have 0.003 of oil clearance, which by the way would actually be excessive. So you'd be like, no, I got an issue. I need to do something different. They actually make slightly thicker bearings that are going to be able to tighten that up to maybe the 1000th goal. But this is why you would do it. These are two tools that you can use to check bearing clearance, but there's another way. We're going to actually come back to it. And then the bore gauge, like we talked about, this would actually be a little bit more of the preferable. But again, I wouldn't use this on a brand new bearing either. Right. So we got demos on this one that I think would be pretty helpful, demo videos. And then if you're not going to use those tools, or even if you did use them, but as a final check, you may consider doing the plastic gauge. So let's make sure we know exactly what plastic gauge does. It is a form of precision measurement. But basically what we're going to do is we're going to drop the plastic gauge in place as shown. We're going to open up the little packet, drop the little strip of plastic gauge, install that main cap, or all of them really. If you're going to do this, you might as well do every single one of them. And this is just temporarily, by the way. And then you're going to tighten up every main cap and every rod cap and tighten all that stuff to spec, including if it's a torque to yield. And that's where this gets a little tricky. If you do a torque to yield torque spec, according to some, that bolt is no good. And then according to Toyota, a lot of times you have to take the bolt out and measure it and see if it has had excessive stretch, right? So there's a debate right there. But to do this, you're really supposed to go to spec. Now, can you get away potentially with not going to spec? Maybe you can, maybe if it calls for 20 foot-pounds at 90 degrees, you just go to the 20 foot-pounds, maybe. But see, the plastic gauge is pretty standard, but you know, maybe not quite as high end of a measurement. So we lay the plastic gauges in there. We put all the bearing caps on, we torque them all to spec, and then we remove all the bearing caps, and then we use this to measure the approximate oil clearance. And if it's in spec, you're good to go. And if it's not in spec, then you got to interpret it. So we've talked about the thickness before, but I'll give you a little bit of a summary. So if you have tight clearance, that means it's going to get squeezed lower. That's going to mush out the plastic gauge more. So a bigger measurement on the plastic gauge smush, the schmia, would actually be a tighter oil clearance. Plastic gauge that doesn't get smushed as much means you have more oil clearance. As long as it's in spec, we're good. Now, part of the reason that we do that is because, like I was saying, there are slightly different bearings available. So like this one, for example, this is journal 1 and 5, and this is journal 2, 3, and 4 on this particular engine, which I believe was the 3UR. So this is a guideline, but these two bearings are actually more wide, and these two bearings are actually more thin. But when we go ahead and we assemble them, you know, they're going to be sitting exactly where they should, and etc. But you'll notice this is a 6. There's no 9. This is just, this bearing's upside down. The 6 number is a specific thickness. Let's say that you picture this, you know, there's an assembly line and they're punching out crankshafts, crankshaft. And as they're punching those out, there's another assembly line punching out crankshaft. Those machine tools, you know, they have bits, and if those bits are worn, they may make a slightly different size. And if those bits are brand new, they might make a slightly different size. The machining is going to be, there's some inconsistencies in machining. Different assembly line is making connecting rods. Different assembly line is making the blocks. All those things get kind of mixed up and jumbled up in the supply chain. And then they come to the final engine assembly plant and they're all being assembled, but they've got 7 different places they've been made. There is going to be some level of variation. All right. So That's why they have different numbered bearings. The number 6 right here is not because it's in the 6th journal. That's a 6 size bearing. So they have a way to calculate, basically like not where the rod was made, but after they make the rod, they do a measurement and they put that into a number. And that number tells you, is it kind of like on the smaller end of the scale or the larger end of the scale? And they do the same thing for the crank and they do the same thing for the block. And then they actually give you something like this. So on the crank right here, journal number 1 is a 0 and a 3. Journal number 2 is a 0 and a 3. 3 and 4 and 5 are 0s and 5s. That's telling you about the crankshaft and how it was measured at the plant where they machined it. Make sense? Then, because we're like in this case, we're going to go with main bearings in this example. We're looking at the fine details of the crankshaft and we're going to compare those to the fine details of the block and where the block was machined. And the block has also got 1, 2, 3, 4, 5 numbers. So it's 06, 07, 09, 04, and 07. And that's just got to do with machining inconsistencies. And they did the measurement after. And then rather than having the final assembly plant do plastic gauge and stuff, they just put a number on the crank, put a number on the block. And then what you're going to do, you ready? You do 3, because we're on journal number 2, 3 plus 7, because we're on journal number 2. You come up with the number 10. Then you would go into the service manual, and the service manual gives you a chart, and it says the number 10 would be a number 6 bearing, right? So it'll give you a range. Maybe like anything between 7 and 12 is a number 6 bearing. So the manufacturer at the assembly plant doesn't need to do plastic gauge. They just need to do 3 plus 7 is 10. Look at their chart and be like, oh, okay, that's a 6 bearing. And then they go ahead and they grab a 6 bearing. Boom, there you go. And their oil clearance will be right in spec because, they've already done all the research on that. They know that 7 plus 3 is 10 and 10 equals a 6 bearing, pretty much. Everything I just told you about that is Toyota specific. That has nothing at all to do with the ASE, but I've always found it an extremely helpful visual aid to see, even if it's a 6.2 liter GM LS engine. They have the same things. The blocks are made someplace, the cranks are made someplace. At the end of the day, the final engine machine, the final engine assembler has to have the right bearing in the right spot. And a lot of times they do have slightly different bearings available. So every manufacturer has their own way to do it. The ASE doesn't align with any of them. The ASE aligns with what we were just talking about. You drop the plastic gauge in there, you smush the plastic gauge. Or technically, you could even measure the crankshaft and measure the bearing and then do the math and find the oil clearance. As long as it's in spec, you're good. So there's that saying, more than one way to skin a cat, which is weird. And I want to make up a new one, but I'll have a new one because why are we skinning a cat? I don't know. And why are we even talking about it? If you do it, you don't talk about it. But regardless, that's the saying. There's more than one way to get the job done. There's more than one way to do this particular task. None of them are wrong, really. They're all fine. As long as you're getting an actual measurement and your oil clearance is in spec, we're good. Make sense? So those are a few different ways. Again, there's a good or better image of the plastic gauge. It's a good image of the plastic gauge. You can measure the plastic gauge width right there and line that up, and that's actually showing a number, but I gotta tell you, I can't tell what number that is. But hopefully it's about 1,000th, or hopefully it's in spec. That'd be the final thing we do. Then we're gonna pop those, well, the caps would already be off by the time we do this measurement, right? But we're gonna go ahead and we're gonna clean all that bearing material or that plastic gauge material off, and then do our final cleanup, and then we're ready for our final assembly. If you don't check the oil clearance and you just skip to final assembly and you have an oil clearance issue, let's just say your oil clearance is excessive. Excessive oil clearance means it's too high. If you have excessive money, you know what that means. You got too much money. I could help you with that. Look, I got a whole plan where I can get you below excessive to like a very good rate if it has to do with excessive money. I got a plan. But you can make it more like if you have excessive weight, that means you need less, right? If you have excessive oil clearance, that means you have too much oil clearance. You need less. So you have your oil clearance is a gap. You have this much oil clearance, but you need this much oil clearance. So you need to reduce your oil clearance. And the way that we reduce our oil clearance would be a thicker bearing, by the way. All right. But let's just say you have excessive. That means big gaps. If you have excessive oil clearance, that's actually going to result in low oil pressure. And that's something we cover in the oil pressure discussion, but we'll cover it just a little bit right now. We're pumping oil through the system, and the oil pump doesn't build pressure, by the way. The oil pump just moves oil. And then depending on the amount of leaks in the system, that determines our pressure. If you have more leaks and bigger leaks, your pressure drops off. Your volume increases, but your pressure drops off. So if you have oil clearance that's this rather than this, you basically have a bigger oil leak. Oil's going to ooze out of that bearing, but it's going to drop your oil pressure. So if you do an engine rebuild and you put it in the car and it has low oil pressure, it may very well be because it has excessive bearing clearance and you screwed up on that rebuild, and you need to really redo that. Kind of makes sense. So when we're doing our build, we have to have the correct amount of oil clearance or we won't have the correct oil pressure. The old school build it in the barn way was just do a high volume oil pump, and a high volume oil pump would generally compensate if you had a little bit loose bearings and you just slap bearings in there and you'd probably be all right. But that was never real professional, right? So that's not acceptable to me. Okay, so then we continue, like it's saying, a dry lint-free cloth, clean it all up. A lot of this has to do with being clean, cleanly. Remember, dirt causes wear. Dirt is friction. Dirt is damaging. A lot of the stuff is, sometimes the difference between building it in the barn and building it in a shop isn't because the person in the shop is smarter. It's just you can't really build an engine in a barn where there's dirt on the ground. You got dirt floors and dirty stuff, and that's gonna all contaminate the engine and cause premature wear. A good overhaul, a good rebuild should last a long time. A bad one will not last a long time. It's not necessarily because the rebuilder's wrench was a snap-on or the rebuilder's wrench was a Harbor Freight. It may very well just be the cleanliness of the building environment, and that's it, right? So now we'll continue. Getting ready to go ahead and measure. You can see this is one of the ways that we do the crankshaft end play. You remember this measurement. So measuring the crankshaft end play, that's when we're using all of our bearings should be installed, and including the thrust bearing. And so that was kind of what we were talking about on this one when we were up a little further. And generally you'd actually want to measure it on disassembly, by the way. A lot of these things you can measure on disassembly, but this was, I believe, just before cylinders. So this, what we were just talking about, this is the same measurement. Your dial indicator is on the crankshaft, and we are using, this is a pry bar. It looks like a flathead screwdriver, primitive Pete style, but this is a pry bar, okay? It was lost in translation. We're prying on that crankshaft this way and then this way, and we're seeing what the maximum number we come up with on that dial indicator. And that's going to be our actual end play spec. So if it's not in spec, that's an indication that you got a problem with your bearings. Not in spec could be too loose, which would mean your end play is excessive. You have too much space. Insufficient would mean your end play should be like this, but you only have this, right? That would be insufficient. Insufficient would mean thinner thrust bearings. Excessive would need thicker thrust bearings to get them both in spec. Okay, so that's kind of your process right here, and that's your visual on how to do it. Okay, so as we continue, A lot of times we're doing a lot of cleanup and preparation. We're making sure that we have new fasteners if needed, etc. We talked about the thrust clearing a little, I think enough. I think we're good on thrust clearance. Now, when we talk about installed piston height, that's a different observation and measurement. And this is not going in order of how you assemble it, by the way. This is giving the different concepts you're worried about. But a final piston related check, that means like when you're done with the build, you actually want to roll it over, and there's a thing called piston to deck clearance. So what that means is you're going to roll the engine over and you're going to bring the piston up, and then you're going to set a straight edge on the deck of the block, and you should have the piston maybe that much from the top. You should be able to slide a feeler gauge and be like, okay, this piston is within 30 thousandths of the deck. You should be able to do it on all the pistons, on every cylinder. The reason why, let's say we'll use Edward's truck, for example. His truck last year had a head gasket failure. When the head gasket failed, a lot of coolant went into the cylinder. When the coolant goes in the cylinder, you can't compress a liquid, so it had the potential to be hydro-locked or hydraulic locked. When the piston goes up, if there's liquid in there, the piston can't compress anymore. It can actually bend the rod, right? So you had a rod that was straight, and they have a rod that's bent. That makes the rod crooked. That makes the rod shorter. If you were to roll this over, that bent rod wouldn't get that close to the top. You'd have, let's say on that 1GR, 6 pistons, 6 cylinders, 5 pistons go like this, 1 piston goes like this. That's a big problem. It's hard to tell when a rod is bent. You look at the rod and you're like, oh, it looks straight. The better way is to check the deck height or the piston installed height. So if one of those is excessive, that means the rod is bent. You need to get a rod, right? So that was part of the thing that we did on his after we saw that it had coolant in the cylinder. We knew it had the potential to be hydrolocked. If you're doing an engine for an unrelated thing, this is a good thing to do. If you're doing an engine for a hydrolock, this is a very critical thing to do. And I've had other ones like a Duramax diesel at one point that had a misfire, and the misfire was a tough diagnosis. And let's say it was gas for a second, you could do spark plugs and coils, and on both diesel and fuel and gas, you could do injectors, and you could do a valve adjustment check, and you could do, you could check the rings, and this one had low compression, but it had passed the cylinder leakage test. And the way we actually ended up diagnosing it is pulling the head off, turn it over, and finding, hey, one of those cylinders pistons doesn't come all the way to the top. Got a bent rod. That was the misfire. The bent rod caused the misfire because it reduced the compression. Didn't make enough compression to actually fire the cylinder. So these are all details that we need to do. There's your example. This one's actually using a tread depth gauge, and you could laugh, but that's fine. We're just looking for consistency. We need them all to be the same. Cool. So continuing. Again, when we talk about the piston to the cylinder clearance, this is going to give you a little bit of a run through on that. We're going to measure at the skirt right here. You might actually be using the dial bore gauge, which would be good. We're setting the dial bore gauge up with a micrometer. They also have a setup jig for the dial bore gauge, but let's say that it was 4.000 bore. We'll go ahead and we'll set 4.000 on that micrometer. Then we'll set the dial bore gauge in there, right there, and we'll hold it at that point, and then we'll go to the dial bore gauge and make it read 0. Now, if you stick it down in the cylinder and it reads 0, you got a 4.000. Yeah. But if the dial bore gauge reads a +5, that means you have to add 5 thousandths to your 4.000. So you come up with 4.005. Make sense? So that is how you measure with the dial bore gauge. Then you could whip it, crankshaft axial to thrust, and you could be like 0.000, 4.000, 4.005. Boom, I got 5 thousandths out around. You could do it quick. Or maybe it's 4.000 at the top, slide it way down, 4.00, let me do it backwards. 4.000 at the bottom, slide it up, 4.005 at the top, you got 5 thousandths taper. So, right, that's, again, there's a video, but to help you understand, that's how a dial bore gauge can be very helpful. Measuring at the top, measuring at the bottom, sweeping it. That would be excessive. That thing's got 17 thousandths of something on there. That would be like a whole lot of taper or wear, etc. Okay, so trust me on the video is going to help you with that. I actually might make a new video. And then on assembly, remember, it's about cleanliness. It's about making sure any parts that are machined have been excessively cleaned. It's about making sure you've measured everything you're supposed to measure and everything is ready to go. And then on the final assembly, it's really about being clean. So you can tell starting these should be smooth. If you're dealing with bolts and they're rough going in, you got metal chips or you got dirt or something in there, that's all got to be cleaned out. And that's one of the reasons I really like the school, how they have that sonic tank and they have that hot tank cabinet. They have a lot of stuff to really clean these engines. If you're going to build an engine in the barn, how are you going to clean it? You going to clean it with the dirty red rag that was sitting in the dirt? I mean, like, so a lot of times the quality of the overhaul has to do with the cleanliness. It just does. Right. So when we're installing these, like, for example, this is just an overview. This isn't the exact details, but some tips and tricks would be like when you're installing the piston rings, the pistons with the rings on there, you got to be really careful about how you get that ring compressor set up. Those are directional. Sometimes they're right side up, sometimes they're upside down. I'm going to tell you the truth. This is not a great tool. The really nice ones are solid. They come from ARP. It's basically like a sleeve that fits one particular bore. So if your bore was 4.000, you would get a 4.000 piston ring compressor sleeve and you just slap it up there. You don't have to necessarily, like, this has these clamps right here. You don't have to tighten those up. It's just made for that size. The negative of that nice ARP solid sleeve one, it only fits 4.000. So it's pretty typical that people will own like a set of these piston ring compressors that can fit like all sizes, but they don't fit really that well. And when you go to pop this in, if it's not compressed perfect, the ring will catch the edge. It'll bend the ring and then it's messed up. And then you got to get a new ring or rings. And, assembling this is not as easy as you think. It's just the way it is. Right. And then we talk about the bearings. Again, it's talking a lot about making sure they're in the right position, making sure they're the right bearing for that spot, making sure, see this hole right here, that hole has to line up with the lube hole. If you were to accidentally put the bottom bearing on the top and the top bearing on the bottom, you're going to block off those oil ports and that's going to get no lube. Like this right here, these are partially blocked off right here. Right. So we got to make sure they're right where they're at. And a lot of times it'll actually call to center the bearings and do a measurement right there. So the measurement needs to be above a half and below 1.0 millimeter, like these types of things. Additionally, what's it say right here? Do not allow coolant to come in contact with the bearing's inner surface. If it does, it's going in the trash. That's crazy. Just one drop of coolant on this surface right here, trash the bearing. Now, I don't know why you'd have coolant in contact with it anyway, but it's not saying that for the outer surface, by the way. But if you read in the text a little bit further, it does specify do not, under any circumstances at all, today, tomorrow, or ever, put oil on the backside of these bearings or grease. We don't put oil and grease on the backside of the bearings. We need the friction right here to prevent that bearing from spinning. You don't want to lower the friction on the outside. That's going to make it more prone to spinning. You do want to lower the friction on the inside, which is why if coolant touches it, it goes in the trash because coolant and coolant's water. So we'll call it water, right? Water and oil don't mix. So if water gets there first, it's going to be very difficult for oil to stay on there as you do the rebuild, which means you're going to get a dry start on that bearing, which means it's going to wear. Roberto, go ahead.
So when putting those on, you would put oil on it, or could you put I think it's called assembly lube?
Exactly. So no lubrication on the backside, and we do have a slide on assembly lube, but I'll give you a little preview. When we set these in, the backside should be dry. assembly lube where the crankshaft is going to contact the bearing, amazing. Technically, oil's okay, but oil's kind of runny and it tends to run off. Assembly lube is a thicker version of the oil where you can glob assembly lube on there and the assembly lube will stay. And that way, when you go to do your initial engine startup, everything's still lubed, right? A lot of your wear comes on that initial startup. So the more well lubricated we have it, the less wear we get on the initial startup, the better quality the rebuild. And that's kind of what this is all about. Right. So very good. Now it talks about doing the measurement in a different way. It talks about when we go ahead and do those bearings, there's a very specific torque. So I could run you through all the manufacturer stuff, or I can give you a parable basically, which is going to be a story. In fact, it's not exactly a parable because it's just a direct story, but I'm going to tell you a story about one of my friends and what he did. And I think you're going to get the point even better than if I try to make all the points. So I had an amigo. He had a Saturn. So Saturns are gone, but he had a Saturn SC2 red. He had like, white 17s on it. He loved the car. He worked at the Saturn dealer, so it made a lot of sense. We were GMA students together. And he beat on that car pretty bad. I specifically remember we went to like a little burger place and he got the two rear wheels up on the little trays they give you at the burger place and was sliding that car all over the parking lot. We did have some fun. So he ended up killing his engine one way or another, probably not really taking great care of it. Then he's like, I'm going to rebuild it. And we took engine class, so we knew some stuff. But some stuff when you take the class, you don't really know what you're doing until you do it with the experience for a while. Okay. So he's like, I'm going to rebuild it. But the thing is, he's a little more similar to me. He didn't have a real good place to work on it. Me back then, that is. He didn't have a real good place to work on it. He was literally doing it in the barn. So little old country boy, he was doing it in the barn. He took it all apart. He got new bearings. He cleaned the stuff up the best he could. He went ahead and he put the bearings in, but he also didn't have this thing called a torque wrench. So he's like, I don't need a torque wrench, right? So now some things I'm gonna let you guys slide on, and other things I know you use the social media thing, and there's a guy saying you need a torque wrench, and it was funny, but the homie said, yeah, I don't need a torque wrench. I got the feel. You know what I mean? I know how tight to make it. I'm just gonna tighten it how much it needs to be tightened. So he just goes to these main bearings and these rod bearing bolts, and he just tightens it the amount that he thinks. Does anybody here think that that's going to be a problem? Just tighten it the amount that you think. Like on some things, maybe you get away with that, but on this one, heck, you can't get away with that like at all. That's like that's a big no-no. So he goes ahead, tightens these up the amount he thinks. He gets the engine started. It ran for, I believe, 30 seconds. It went locked up, right? So we see everybody in school the next day. We're like, hey, where's the car? Thought you were going to have it done. Oh, yeah. It seized up on me, so I got to redo it. So he goes to do it again, gets all new bearings, puts all new bearings in, pre-lubes them and everything, tightens them up by feel again. It runs. He's like, I must have over-tightened him, so he tightens them up a little bit less. It ran, I think 60 seconds this time, and then locks up. And he comes in, we're like, hey, where's the car? And he's like, oh, it's seized up again. I got to redo it. And then I specifically remember one of my friends who was one of the smarter guys. And so was the first one. I mean, if you think about it, this is community college and he's rebuilding his own engine, so he's good, but a little dumb in that way. One of the more smarter guys is like, dude, you need a torque wrench. I'm going to come over there myself with my brand new Snap-on torque wrench, and we're going to do it together. And then sure enough, the next day he pulled up and the car was done. And so it was like a perfect lesson of if you don't have these torqued right, your engine is maybe going to run for 30 seconds, maybe going to run for a minute or something. So this stuff is critical torque. And not just like kind of torque it, like actually, torquing it accurately. I would even go to say, I don't think I would use a junky cheap torque wrench. I would do something more high end. You just have a lot to lose on this. he was a hard worker, so he was just staying up all night pulling the engine back out. And plus he worked on those cars all day, every day. So like he was really fast, but to go 12 hours back into an engine to replace the bearings because you had a cheap torque wrench is insane. Sorry. So each of these bolts has a specific torque procedure, process, torque spec, everything needs to be followed. So like in this one, the inside bolts are 45, the outside bolts are 20, and then you do them in a sequence, right? 1, 2, 3, 4, 5. So it's generally from the inside out, kind of like a bumper sticker before Mimi's. You'd get a bumper sticker you'd put on your car. You'd start in the middle and you'd push the bubbles outwards if you wanted to have a nice bumper sticker install, right? It's kind of like that when you're doing this type of process, pretty typical. And then additionally, it actually talks about doing an additional 90 degrees. So as soon as you see degrees on this, you know, oh, this is going to be a torque to yield, which means you're actually going to get the bolt well into the stretch phase. The one way to do this is with a painted mark. And honestly, it's not the way that I would personally do it. So you could make, let's say, if you put the dot of paint right here, then you could measure 90 degrees and put a dot of paint on, let's say, the head or the whatever you're doing. Then you'd actually literally just turn it 90 to make sure the painted mark moves 90 degrees. But it's hard to say that that's really exact. So I don't think it's the most effective. I'll show you the most effective a little later. Okay, that's what I would do. And so now when we're reassembling, there's a couple different types of connecting rods. And one of them is, like it says right here, a press type. And then another one's a full float type. So the press type, you actually would, and the pin is being pressed into the connecting rod. So you'd actually put the connecting rod small end into an oven and heat it up. And then while the connecting rod is hot, it's female, right? So the female part expands. You keep the pin cool, so the male part is still contracted. Then you put the piston in place, and you should just be able to slide the pin in there. Pretty easy. Assuming you had a rod oven. You could even put the piston pin in the freezer, right? Just understanding contraction and expansion. You want the most expansion on the female. You want the most contraction on the male. That way they fit easier. That's a good way to do it. That's not a good way to uninstall it though. When you're trying to uninstall it, you can't heat one part and cool the other part. They're already press fit together. So you actually have to use a press. This is actually on disassembly. I wouldn't recommend pressing it for reassembly unless you had to. I'd recommend using the temperature difference. Okay. The other one is a full float, which means the pin and the connecting rod, it all just floats. The negative of a float is that there's nothing stopping it from falling out. So what you use are these circlips, snap rings, similar. They're going to have something to stop that pin. So this pin can slide all over the place, but these circlips or snap rings stop it from sliding. One reason, and these are very convenient and nice. One reason why they're not my favorite though, I had a Honda Odyssey, not the van, the go-kart little thing. And it had a two-stroke engine. And actually, I got it super cheap because I bought it from a guy who basically rebuilt it himself. And then all of a sudden it wouldn't run. So I traded him something that was worth way less. But I did bring it back. And I have actually a picture of it somewhere. But in fact, let me see if I can do a quick search. It's going to be under this because I actually took a picture of it. Let me see if I can find it. You give me 1 second, and I think it'll help. Right. So I bought it from him, or I traded it from him, and it wouldn't run. And I actually thought it was going to be like a carburetor type of issue or something, but it wasn't. It was it had low compression. So by the time I went to measure the compression was low. I'm like, okay, well, this was a little more than I bargained for. But when I pulled it apart, what had happened was the cylinder was all sorts of scored. Like it had a whole bunch of scoring in it. And I looked at the piston, I pulled the piston out. That little circlip, that little snap ring that you see right there on the screen, it had fallen out. And it not only fell out, it got wedged between the cylinder and the piston, and it got ripped up and down, totally torn up, hammered, and trashed that cylinder. So I ended up having to send the cylinder out, get the cylinder bored, which was okay. I just found, I think I have that picture. The pictures are loading a little slower. And it was kind of cool because I took a picture of the liner all torn up, or of the cylinder. Sometimes I slip up and call it the liner, but man, my pictures are loading super slow. All right, let's just see if maybe open it will load quicker. Slow loading. Slow loading. Okay, yes, here we go. Let me pull these over. This is the machine I'm talking about, right? It looks kind of cool. There's the cylinder. Okay, that's the board cylinder. New piston and cylinder overhaul. There you go. Right there. If you guys look at that, that's a good representation of a score in the cylinder that would actually drop the compression. So you can see that snap ring or that circlip fell out the side and got ripped up and down the cylinder wall. And if you look, that's deep. That was really deep. That was deep enough to drop compression and cause the thing to have, it's one cylinder. So if you have compression that's low on one cylinder on a single cylinder engine, it doesn't run. On a car, if there's 4 cylinders and one cylinder has low compression, that means it's a misfire, right? So that was actually a misfire. Now I'm going to reference this pretty heavily in unit 6, I believe, which is engine diagnosis. We're going to talk about the causes of low compression and cylinder leakage and stuff. And this is one of the things that could cause oil consumption, could cause low compression. And on a cylinder leakage test, it would cause air to be leaking out of the dipstick or the oil cap. Okay, this is all bottom end cylinder leakage. There you go. All right, and then compare that one more time. There's the new piston. And if you look at that cylinder liner, that cylinder, nice and clean now that it's been bored, right? So that was the fix for it. So I didn't end up upside down, but like I definitely didn't make out quite as well as I thought. It was still a good experience, and now I'm able to share that experience, even though it's not exactly car related. It's still the same concepts. Okay, now let me get rid of this picture. Okay, so continuing with the different types of rods. So piston pin slide in, you would probably prefer the floating, but I'm just showing you why I'm a little weird about it, because now you see one of those, how much damage it caused for me. Then when we go to install the crankshaft again, you got to know if the crankshaft is factory size or if it's been undersized. If the crankshaft had a score and it's been undersized, you need undersized bearings. So a big part of what we're doing when we're doing these measurings is we're checking for defects. But the other thing we're doing is checking to see, has this crankshaft been machined? Has this cylinder been bored? Because you need to order parts. You need to order connecting rod bearings. You need to order main bearings. If you order regular ones and it's been machined, they're not going to work. If you order piston rings for the factory size, but that cylinder's been bored 10 thousandths over, they're not going to work. So this entire time we're measuring and comparing to spec to determine, do I need oversized, undersized? You know, what do I really need? With that being said, once you get the right ones, you keep these in the plastic bag till you're ready to install them. When you're ready to install them, remember, you can't get any oil on the backside. You can't get any contaminants or coolant on the actual bearing side, right? Making sure they're all right. Now we've got the bearing in place here. And yes, we're doing a type of assembly lube there, kind of like what we had talked about. And before we do this, we would have done extensive cleaning. You know, the block, everything will be clean. Also, see this oil passage right here? That's how oil gets to that bearing. So if you were to have a bearing that was spun and damaged, you can pack that full of metal debris and shrapnel. You could rebuild the engine with all new bearings and all new crankshaft and all new everything. But if oil doesn't make it to that bearing, you can see how this bearing is going to starve for oil and wear out prematurely. So going through part of the cleaning process is blowing all these holes out and making sure everything is super, super clean, no debris, no lint, so even the type of towels that we're going to use is going to be specific. Lint-free towels, pretty important, right? So on the assembly, and then getting that bearing installed on, let's say, the rods, clean hands, or better to use the gloves actually. You notice this bearing's being snapped into place and it has this little tang, this little retainer has to go in that little groove right there. You have to line those up. That's to prevent the bearing from spinning. If you don't have it lined up, you're going to really mess it up. But additionally, just know it's to prevent the bearing from spinning, especially if it gets a little bit of friction in there. Okay, so everything is set exactly where it's supposed to be. Then we go to drop this crankshaft in. We'll have all of these bearing saddles all pre-lubed with assembly lube. Now, for those of you who've done the overhaul, nobody came and asked me for the assembly lube, which is normal because, we hadn't lectured on this yet. But for everyone else from here on out, when you go to do this, I'll get you the assembly lube. But, I'm keeping an eye on the people who are pulling engines out and stuff. So sometimes I forget to set the assembly lube out. Come get me. We'll get the assembly lube. It's almost like honey oil. It's thick. You goop it on there and it kind of clings. And then when you set that crankshaft in there and you spin this crankshaft, it just glides across that nice assembly lube. It's nice and it does help. Now this is kind of backing up to plastic gauge. Just to remind you, you should have already done the plastic gauge before we're doing the actual assembly. But just in case, this is going to run you through how to do the plastic gauge. There's a strip of plastic gauge laid in. Assemble the caps, torque them to spec, like this. And then you can pull it out and measure it. And there's your measurement, right? Just making sure. But then you have to clean all this up and then you have to do the assembly loop. Okay. So make sure it's totally ready. And then a lot of times when we're doing this thrust bearing, first off, the thrust bearing can be two types. Sometimes the thrust bearing is, let's say, like on the number 3 main bearing saddle, and it's sort of like built in. It's not just a shell looking bearing. It's a bearing with like a collar on the side and it kind of clips into the block. Those actually tend to be a little easier. Those you kind of pop in and then the crankshaft just fits tight right off the bat. But other types, they're actually more like a U, like a U horseshoe shape. Those ones you have to drive the crankshaft to one side to make room to slip the bearing in place. And then a lot of times you have to drive the crankshaft toward the bearing. Sometimes you have to do a bearing on the other side pretty commonly. So you may have to hit it one way and the other way. Are you going to smack right on the crankshaft? No, don't do that. The wood is going to help absorb the impact and not damage the surface of the crankshaft. So right here, that's where your flex plate or your flywheel bolts up. You can't have that thing all marked up, right? So keeping it clean, doing nice. Now, this is another way to measure end play, but it's not real commonly done. Seeing what size feeler gauge goes between the thrust bearing, which is on the side, and the crankshaft, which has a machined surface where the thrust bearing sits, right? I personally wouldn't use the feeler gauge, but you can. If the ASE were to show something like that, that could be measuring crankshaft thrust, or it could be measuring connecting rod thrust, the connecting rod to the crankshaft journal thrust clearance or end play. But I wouldn't do it like that. I'd say the dial indicator I think is a better deal, because if you have new bearings in there, you really want to be sliding that feeler gauge up against your new bearings. I really wouldn't. Now, when we're installing the piston, right? So that would be the whole bottom end. You got the bottom end assembled, you got it pre-lubed, you got it torqued. The bottom end should be good. You should be able to turn that crankshaft and it should be smooth. And there should be no excessive end play or anything. So you got to do this methodically. You got to make sure that's good. Then when that's good, you can get into dealing with the piston rings and the pistons, right? So we're going to have to be very careful putting the pistons in. You can mess the rings up. It's really easy. Notice some of the rings have different marks, right? You might have a number, you might have a letter, you might have a dot, a circle. So you have to understand what mark you're looking for and where it needs to go. And we'll explain that a little bit more. So let's just say that you get ready to do cylinder number 1 piston. You should have the piston installed on the rod with either the press fit piston pin or the floating piston pin, and you got to make sure those retainers are all the way in the groove. Because if that retainer comes out, you can see what it'll do to that cylinder. It'll shred that cylinder up big time. Now, when we go to install the pistons, the rings, Roberto, is your hand up? I'm sorry, I missed that.
Yeah, just a quick question about the rings. When you're measuring the gap for the rings,
Yeah.
and if it's not in spec, can you sand them down to get them to specification or not?
Aftermarket rings depend. So I actually don't have a set of rings in front of me, but if you were to look at the ring, it comes to an arc, right? And there's this thing called the ring end gap. With OEM rings, you should not have to worry about any of that crap. You should, and not even OEM, but like an OEM style replacement. You should be able to put the rings in place, and they should be good to go. But with some of these aftermarket, they're high performance custom builds, like turbo pistons with these rings and whatever. They'll actually have you put them in, and the rings will be longer than they can really fit. So you go to try to put them in, and the ring will bind on that gap, right? The ring will actually hit the end gap. Those have to be filed. So not exactly with sandpaper, but with an actual file. File I do have. So here's my file. I go ahead, I take the file. I could actually file the ring end gap, okay, to get them in spec. But that's more custom, aftermarket work. What we're generally going to do from the factory is you could take the ring and you could start it in the cylinder, right? Just compress a little bit, start in the cylinder, use the piston to drive it down a bit so it's nice and square, because the piston is going to make sure it's square. And you could actually measure the end gap with a feeler gauge installed. And that's how you're going to make sure that your end gap is good. Generally, we're not real worried about that, about having to file them for like an OEM style rebuild. However, that can give you a lot of information. Remember, we talked about measuring the cylinder for taper. So if you've already measured the cylinder for taper, this doesn't help. But if you don't have a dial bore gauge, you could put that ring in and you could measure that ring down at the bottom of the stroke at BDC. And let's just say you have 60 thousandths clearance on that ring. And then you could pull it up and measure it a little bit below TDC, like at the maximum travel of the rings. And let's just say you had 90 thousandths clearance. It was less at the bottom and it was more at the top. That can tell you that the cylinder's tapered. So if you're trying to do like the homie in the barn, rebuilding his engine, and you don't have a dial bore gauge, you can actually slide one of the old rings in there and measure ring end gap at the bottom and ring end gap at the top and tell if your cylinder's tapered. Just cool tip for you. And ASE sometimes asks a little bit about that type of thing. But now when we go to install the rings, there's a couple of details that you must know. It's not uncommon to just take the ring and just kind of like roll it in a circle, right? Like start one in and kind of work it on like it's a tire. But that's not preferred, because you're actually the rings are strong like this. The rings aren't strong like this. So you can actually warp a ring pretty easily. It actually talks about using the ring expander. That's what this is. This will expand the ring enough to get it on. It'll grab the ring, spread it out, and you should be able to slide it straight on. That's the preferred method to get them in the grooves, right? And then additionally, it talks about, what order. You're probably going to do the lower oil ring, then you're going to do the middle compression, then the upper compression. But it also talks about where you're going to orient the gaps. It may say, put the upper ring gap, the upper oil control ring gap here, the lower oil ring gap 180 out from there, the second compression ring gap right here, and the upper compression ring gap right there. So it will have, in service information, it will have a specific angle to put the rings at. And that's important. You should do that. Do you need to get the protractor out? No, you should just be able to know, here's a 30 degree. If this is the axial, right? You got a piston pin right here. You should know about 30 degrees down, second ring gap, about 30 degrees up, upper oil control ring, right? So not necessarily with a protractor, but right in that general area. Get all those ready, inspect. Now, I told you something, a story. Remember the UAW assembly line workers were very upset that they didn't get the pay raise. So what they did at one of the GM plants back in the day, they took the compression, all the rings, and lined them all up, and they made them all in line, and that actually made it drop compression. Those engines had to be disassembled, spin the rings into place where they're supposed to be, and reassembled. So this is, and if you do this wrong, you can make the misfire, and you can make it so you have to redo this job. All right, so it's critical. Then here's your piston ring compressor. This style with the clamp, is pretty common. You loosen the clamp, put it in place, you tighten the clamp, that should compress the rings. You should be able to slide it into place. These other ones are actually more common, like in a shop. This is like doing it in the barn at home. This is in the shop. You got a lot of different sizes here, and you're going to use these pliers to basically compress them, and then the pliers have a locking mechanism. We have some of those. All these are okay, but I'm telling you, that solid sleeve, if you got the right size, is nice. But you got to have one for every single engine bore that you're going to work on. All right, so when we go to assemble those, like for example, this piston ring compressor sometimes has little tabs, but they typically have a bottom and a top. If you have it flipped upside down, it's not going to really help you compress the rings. It can be a little tough, and you're going to want to put some oil on those rings to help get them in. And if it's going well, you should be able to get those rings in and just kind of like get it below the surface of the ring, just carefully with the lightest little taps of the wood end of that hammer, just the lightest taps. Sometimes just with your thumb, pop, 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 it should pop it in. All right, as we assemble it, use a lot of care. Now, this is a detail that's commonly overlooked. If the connecting rod has studs and nuts on the cap, like a lot of times our connecting rods are bolts, okay, so those are a little easier. But if your connecting rod has studs and you're trying to pop the piston down in, that stud can hit the crankshaft and mark and damage the journal. And if it does, that crankshaft's got to come out and be repaired, which means you're starting over. You're starting the build over. So sometimes they have protectors. Sometimes what I'll do, I'll move that journal down to bottom dead center. So that way when I pop the piston in, the piston is still, just starting, and the connecting rod is like this far away from the crankshaft. I can't hit it if I can't touch it, see? And then once I get the piston down a little, I'll flip the engine back over and I'll rotate the crankshaft in while I can kind of like manipulate the rod and just get the rod right here and let that crankshaft journal, sometimes called the piston, sometimes called the crank pin, come in and just land right in the saddle, which is all nice and pre-lubed. Get the bolts in, get the cap in, boom, and then just lightly snug those up and move on. So when we're assembling these, you can't be banging the pistons in. You can't be having the connecting rod hitting the journal, the connecting rod studs hitting the journal. You got to have all that stuff needs to be very precisely and carefully installed. So if I'm installing an engine, be honest with you, my ideal is I go into a room where no one can get to me. I turn my phone off, and everybody needs to leave me alone so I can pay a lot of very careful attention, because I don't want to make a mistake. And I also need to be very focused when I'm doing stuff like getting these pistons in and getting these journals handled and not forgetting to torque things, right? So that's the preferred. If you guys thought building engines was going to be like being trackside at the racetrack, not really. I'm sorry. It's kind of boring. It's quiet. It's isolation generally. All right, and so you can see we're not even using the plastic handle here. We're using the dead blow soft handle. That's great. No problem. So here we are getting the piston down into place. Pretty cool. Right, you might have to do just a little bit of a tap. And then again, checking that piston deck height would be a good idea. I probably would have done that on the disassembly, to be quite honest, but it's a good idea. All right, and then a lot of times, let's see, we could do some of just like the final things if we're doing an overhaul, by the way, we may actually be like painting it or cleaning it or whatever. You have to understand when you do that. Like the block would probably already be done. Sometimes you assemble the engine and paint it after the fact. So just wanted to put that thing in there because a lot of times what we're going to do pretty soon is start putting the plugs in. So if you've got all your assembly done and it's time to drive those freeze plugs, you paint it before you can continue the assembly. Makes sense? You don't do the entire assembly and then just spray bomb everything. That's not, wouldn't be professional. You guys probably aren't going to paint your engines anyway, but just saying, back in the day, engines used to be painted. They were cast iron blocks, not aluminum. So that would be pretty typical in a rebuild. Mask it all off, paint it, but ideally before you even get some of those plugs and stuff in, you paint it in parts. Cool. And so generally I think you get the point. Now after we paint it, now we're going to put engine plugs, sensors, seals. Like, so this is the rear main seal. This seal is really nice because this seal was driven into its plate already and then installed. Sometimes driving it onto the crankshaft is tough. They do have a tool that threads into the crankshaft that'll pull the seal on. You guys working in the shops, you know, we tap seals in a circle sometimes. I don't know that you'll get away with that on a rear main. In fact, I know at some point you will not get away with that in a rear main. Think about the work it takes to fix that rear main if you mess it up. So they generally have a special service tool to drive that rear main in, and I would use it. And in fact, I've had to redo a couple rear mains because I didn't have the special service tool. And I was careful and I drove it in and it leaked because it gets deformed. It's just a big flimsy seal. It's not like a smaller axle seal. It's big and flimsy. And if you are tapping it and it gets just a little deformed, it's not going to seal. So continuing on the overhaul, right? Doing these soft plugs. So like this plug has a sealant on it. Sometimes it's Teflon tape, sometimes liquid Teflon. This is true for anything that's going into an oil or coolant passage. You know, we're going to have a way to seal it. You go getting ready for that freeze plug. We're actually putting adhesive and then driving it in with the driver. This would be after paint if you are painting. Same with a lot of these. They have special drivers to drive them in. Right. There's still more to the assembly, by the way. And similar with these, you know, torquing them to spec and whatnot. Now, there's a little bit more on the rings that I wanted to add because you got some of like the generic text methods. Some of this is going to be a little more Toyota specific. So on the Toyota specific, it actually calls out the positions that they want. The upper side rail at 12. The number one ring a little before 3. The side rail lower, and the side rails, by the way, are the oil control ring parts, but not the spacer, right? So your lower control ring for the oil ring is down here, right? This is the upper and this is the lower. So it talks about all the positions for that. And then also the position of the piston direction is specific. It has a dot and that needs to go towards the front. Sometimes they have an F. So you'll be following service manual pretty closely. It'll be kind of walking you through, but just to get you familiar. And then Toyota also recommends the piston ring expander, but they added one more thing that was kind of interesting. If you're reusing your pistons, a lot of times they'll have carbon. So if your pistons have carbon in the ring grooves, you got to clean it. This is a ring groove cleaning tool. So you're actually going to set it up and it's going to drag a little cutter through the ring groove. But if you're doing this in the shop, a lot of people won't have that. There's another thing that we do pretty commonly. You take one of the old rings and you break it. Do it while it's in a shop rag or something because they're jagged. If you go to break it, they can be pretty sharp. You break it and then you use the old ring that's got a broken rough edge now and you can scrape all the carbon out. And you can also hot tank them and clean them really good and scrape it. If you have the carbon in there, the ring can be kind of seized and the ring can expand and maybe move slightly. So we want to make sure we get all the carbon cleaned out of there if you're reusing the pistons, which you commonly do, right? And so that's kind of what it's showing once again. And actually, some of this was doubled up. My fault. Should didn't catch that. Now, when we're getting ready to do, we got the bottom end assembled, right? When we get ready to do the top end, the top end was unit 2. So the head in this procedure will already be done. This doesn't get into doing the valve adjustment, doing the valves and stuff like that. This just gets into the assembly, which means now you're ready. We're going to get ready to install the head gasket. Make sure that there's no oil on the head surface or on the block surface. Make sure everything is clean. There's actually quite a bit of lesson on gasket prep, but this is mostly really on assembly. Head gaskets can be different side to side. I kind of told you about that already. They can be directional in which way you put them. Sometimes they say front, sometimes they say top. You got to know exactly how it goes. And if you put a head gasket on, especially the MLS style, and you torque it to spec, that head gasket's done. If you have to undo it because you forgot something, you need to get another new head gasket. Okay, so that's kind of what we're talking about. This one, for example, shows front. So you know which way that one goes. Make sure all the holes line up. That was a step that I skipped on the one I told you. I ended up having a head gasket on wrong and it made a huge oil leak and I had to pull the heads back off, get new gaskets. And then like sometimes we have to have the cam removed. So we talked about assembling the head. If it's a dual overhead cam and you have to have the cams removed, you'll be assembling the head without the cams and then you'll be doing the cams later. Okay, but that was kind of like last unit we talked about how to get the cams on. Notice that a lot of times they have dowel pins. If you sent it out to the machine shop and the machine shop like decked the block or decked the head, meaning they straightened it, it's not real uncommon for them to have pulled those dowel pins and forgot they pulled the dowel pins and you don't have the dowel pins. You need the dowel pins. The head is not centered on the bolts. The bolts in the head are sloppy. The dowel pins are precisely machined to locate the head exactly where it needs to be. So if you have a missing dowel pin, that head gasket is not going to be sitting in the correct spot. It's going to have some issues, leaks, similar, right? So we need those. We need them. They're very important. Now, when we're doing head stuff, and a lot of times that bottom end is the same, like we talked about, it's torque to yield. So remember I said we're going to come back to torque to yield. We are. A lot of times these head bolts are torque to yield. In fact, the majority, if not maybe on a current like 2024, it's probably going to be all of them. Head bolts are going to be torque to yield. So a lot of times it calls for starting all the head bolts and then doing one pass in a specific sequence and then doing another pass in a specific sequence, which may include torque to yield. But either way, it's very critical that the head bolts are clean. Sometimes they call for oil, sometimes they don't. Subaru, for example, definitely calls for oil. If you don't oil them up, they tend to like, when you're trying to tighten them, there's under a lot of tension, there's friction on the threads. They tend to be like pop, pop, pop as you're tightening. But follow what it says. If it doesn't call for oil, then you don't necessarily oil them. I can give you one example, a Duramax diesel, for example. When you order new head bolts, they come in like a plastic bag that's sealed and they have a specific type of oil all over them. And it specifies in service manual, do not clean this oil off, put these in directly because they came with a very specific oil with a very specific, I don't know, friction, coefficient of friction. A lot of times though, they're just saying like, dunk it in the regular oil that you use, 0W20, something like that. Cool, so clean it, make sure they're good. Now we're gonna go ahead and we're gonna set it right on the dowels. And also, sometimes they have other stamps to help you locate them, tell you which way they go, etc. Again, make sure that we definitely don't have oil on there, but especially where there's going to be sealant like RTV or FIPG added. Okay, that's really critical. And then as we're landing the cylinder on there, it's specify. Do not slide the cylinder around. You really need to go straight on it. If you slide it, you're potentially going to score that gasket up. So it's getting it in the exact spot and right straight down. Cool. And then a lot of times, it'll go into potentially having to set the engine a certain position. So see how this is at TDC? TDC generally is not where we want it. So if we were to turn this engine over a little bit, no pistons would be on TDC. That's generally when you want to install the head. Because on that head, depending on what position it's in, it might have valves that are open. Think about that. If you have a valve that's open on cylinder one and you have TDC on cylinder number one, because remember, they're not timed yet because there's no timing belt or chain. You might actually have the valves hit the top of the piston. And as you're torquing that head down, you might be bending the valves. So just be aware. General rule of thumb, don't have any on TDC. More precise, follow the procedure. And if they want you to set in a certain position, they may tell you in the procedure, right? So we lay it over there, get them started, maybe finger tight. And then right here, I want to pause. I want you to look at this torque wrench. I actually have one below. So that's a torque wrench. It's digital. It's special. A couple special things. I'm actually going to show you something cool. One, look at that picture, and look at that. All right. This is a good torque wrench. This is a digital torque wrench. It's a nice torque wrench. This torque wrench does foot-pounds, inch-pounds, newton-meters, whatever. But it doesn't do angle. And you're like, who cares? I don't care about angle. Why do I care about angle? Well, let me tell you why. I have that one. That was the one I bought when I was at your stage of the game. The reason I went digital on that was I thought, well, if I buy digital, I don't have to buy a 3/8 and a 1/4 inch. I can just get a digital because they're so accurate. You can use it as a 1/4 inch with an adapter. It does inch pounds. But then as I got a little more experienced, I realized it would be better to get a torque to yield. So this is a newer one, and this right here is an angle symbol. So if I were to turn this on, okay, it's coming up. Give me 1 second. It's now zeroing for torque to yield. Okay, see that number? I have to hold it still because it's measuring what angle it's at right now. Because I left it set up for torque to yield. So if we have to tighten them to, you know, whatever, 20 foot-pounds. In fact, I'll set this down and we'll come back to it. If I have to set it to 20 foot-pounds and then it says an additional 90, like we were talking about before, you could probably pull a 90 off. But what if it calls for a 70? 70's gonna be tough. You might have to get your protractor out and all sorts of stuff. So what I would do, I would really recommend getting a torque wrench that can do torque angle. Because if you do, when you go to do this and it calls for do this, and then 90, you push one button on here. Oh, you want 90? No problem. Boom. And then notice when you turn it, it'll count up. Okay, it's a little tough for me to do, but it will actually start to count if you have it on the right spot. Like that was just clicking it. But when I turn it the right way on a bolt, it'll actually count. Let's say you can't get it to full 90 and you have to back up. It'll save its spot. And all you got to do is basically make it hit the 90. Even if it takes you several of these, it'll store it. This is much more precise. If you're going to do these engine builds, I just don't see how you're really going to do a high quality engine build if you're trying to do the paint marks and the dots and stuff. It just doesn't make sense. So with that, if you are going to go with the digital, I would also go with a torque angle so that you can do these. That's main bearing bolts, connecting rod bolts, cylinder head bolts, and sometimes more. I've even recently done some brake work where it calls for torque to yield bolts with an angle. And the crankshaft pulley is pretty common to be torque to yield as well. Right, so that was my little plug for getting the digital that does torque to yield. Snap-on, Mac, Matco, Cornwell, all have them. Probably some other companies have them too. Right, and then remember it calls in a sequence. You got to really be following these carefully. So when I started, I would do jobs, and you know I wanted to do a good job. So I'd bust out the torque wrench all the time. Plus, remember I showed you I had that nice snap-on torque wrench. Right, so I'd be busting the torque wrench out, and some of the older, more senior techs would make fun of me, like, "Oh, you gonna get your torque wrench out?" I was like, "Yeah." And then I specifically recall I was doing a job. It wasn't a really big job. It was like an intake manifold, and the service manager was in the shop, and one of the techs in the shop said, "Hey, you gonna use your torque wrench on that?" And I was sort of like, But at that time, I was starting to get a little more complacent with like, whatever, I'm just going to wing it and stuff. And I wasn't using the torque wrench, truth be told. And I'm half and half now. But the service manager looked, saw I didn't have one. He's like, yeah, you need to use the torque wrench on that. And it was a big laughing stock joke because I'm the one who's over the top with the torque wrench. And now he made this joke, and the service manager thought, like, oh, wow, he's not using his torque wrench. Made me look like an idiot. And it wasn't on something that was real critical. With heads, with crankshaft journals, with that type of stuff, you need to freaking use that torque wrench. You're gonna end up like my friend who built his engine 3 times in the barn. Okay. For me, listening to someone tell it to me doesn't always hit, but like when I had a friend who had to do his engine 3 times, the first 2 failed because he didn't have a torque wrench, and the third time where there was a torque wrench, and then he drove it to school. I'm a believer now. So, I know that the torque wrench makes all the difference on the engine rebuilds. Cool. And with head gaskets too. So if you don't have the right bolt tension on the head gasket, that head gasket's got a tough job. It's got to clamp and seal a lot of stuff. Now, when we're doing this, you can see you can use a paint marker. They even make this. If you don't want to spend the money on the digital that has torque angle, you could actually get one of these, and you can put this on a little extension. And as you turn it, you could pick a thing you're going to index to, like maybe this thing, and then you're going to turn it, and you'll bring the 0 to that thing, and that's how you get the 90. So you can buy those. They're a little cheaper. They actually make one like this that's an adapter that will make any tool torque angle. It's digital. You turn it on, you set the angle, and then it measures. It basically does the exact same thing as the tech angle or the torque wrench that measures angle, but you put it on the extension or on the socket. It's its own self-contained device that looks like this, but digital. It's kind of neat. And then again, if you did the dots, you make sure they all face the same direction. Now, this is something that could be put in several spots, but it makes a lot of sense for the bottom end. When we're going ahead and doing the final assembly, remember, we got to have everything sealed. So there's been times where we pull an engine out to do an overhaul just because it leaks. That's actually pretty common on like something older. So I got hired at an independent shop really just to do diagnosis work while I was teaching and kind of building my career up. So I couldn't work in like a dealer because it was like, hey man, I can work maybe like 1 day a week. So this shop's like, yeah, we'll have you do the diag. Or really what was happening was I'd go work a few hours a day in the morning only and then leave to go to sleep because I was working nights, if you must know the detail. I was working nights on the railroad while still teaching. It was a gnarly schedule. So I'd go in just to do diag. And then one of the times he brought a car in when I wasn't teaching, I had a little bit more time. So I would do more like heavy line work too. And they brought a car in, and it was a Saab. And the customer concern was oil leaks. And there was like oil everywhere. And so they told this customer, look, if you really want to fix this, we're going to have to pull that engine out and do a full reseal. And she was sort of like, I don't know, but she loved the Saab and her daughter was going to drive it and whatever. So she agreed to pull an engine out to fix an oil leak, and it was expensive. Now, when I got ready to do that, it was sort of like I could reseal it in the car. But if you're talking about doing an oil pan and the upper oil pan and the valve cover, 1 or 2, and a timing cover, like it's going to be a lot of work to do all that. A lot. So pulling the engine out kind of made sense. The long story short on that one, I ended up pulling it out and resealing everything, and I put it back in, and it puked oil. And it was like, what the heck? So I looked into like the PCV system and stuff we kind of talked about, how the PCV system will reduce crankcase pressure and it'll make it so seals don't blow out. But ultimately, on my diagnosis, I found it actually ended up being the oil pressure sensor for the dashboard was leaking through the sensor into the harness and just making there was oil everywhere. It seemed like the oil was leaking in 10 different spots. And it probably was a little bit, but the main bulk of the oil was actually an oil pressure sensor. I didn't diagnose the oil leak, by the way, so I can tell the story without like a guilty conscience. When I put it back together, I'm like, hey, it's leaking. And he's like, did you mess something up? Because when you go to do this reseal, especially with this RTV or FIPG, you can make mistakes. These cars are coming from the factory with oil leaks, and they were assembled by somebody who assembles these all day, every day. So getting it sealed good is not that easy, right? So he thought I made a mistake. I ended up diagnosing it as an oil pressure sensor, put a new oil pressure sensor in and clean it up. It was good to go. And they were sort of like, ooh, well, yeah, let's not really we're just going to eat that. They covered the oil pressure sensor. They didn't even really, they told the customer they replaced that too, but they didn't call her and say, you need to pay more money. They had just charged the customer to reseal the whole engine when the bulk of the leak was actually a sensor. So several lessons in one there. But when we go to reseal these, there's a extensive amount of gasket prep that's needed. So like, let's say we get ready to go and do this oil pan. If we pull this off, we got to do a lot of cleanup on that. One of the main things we'll be using is a razor blade. Razor blade's going to get the bulk of the material off. If it's aluminum, you're technically supposed to use a plastic razor blade. You could use a scraper. So like I have a scraper right here. This is actually like a scraper. They'll call it a gasket scraper, but it's metal. You can scrape gaskets. Probably a razor blade would be my go-to, and the reason why, because you can keep the razor blade pretty nice. So this one's on a handle. You can swap the blades. I have a couple. This one is always pretty cool. This is a mini. I mentioned the plastic razor blade. I've also got that. So this looks like a razor blade. It fits into the holder like a razor blade, but it's plastic. So if it's aluminum, it can't. A razor blade is actually able to cut into aluminum. So when we're scraping, and you can scrape like this, which is good to get big steps, but you can also come back and kind of square it up, and you can do this. You're wrecking the razor blade, but who cares? It's disposable. You throw it out, right? However, if you over scrape it, you could actually make a low spot, at which point the gasket won't seal that. You won't get enough clamping force with the gasket. You gasket prepping incorrectly will make it worse. So just be aware. Then one of the final things that I'll do, people use sandpaper too. Sandpaper could be good, but if you're going to use sandpaper, it needs to be really flat. If you use sandpaper on your fingers, you don't really hold them flat enough. Another thing that I personally like, which I have, I got it right here. This is a cookie disc. You see why it's a cookie? But this is good for rust and stuff, but this would not be good for gasket prep. This is way too coarse. And additionally, you see it's fiber. Look on the backside, you can really see. The fiber will end up in the engine. This, along with the FIPG, along with the dirt and debris, will end up in the engine, and it'll clog up the sump, the pickup, oil pump pickup, and you'll kill the engine. Now, all right, I'll be really honest with you. When I was brand new, I didn't really understand that concept very well. I think I'd taken the high school class, and I think I was in my first semester of community college, which was electrical. But like you, many of you, I had a piece of crap truck. Her name was Bessie. I got a picture of it, but I'm gonna save you that. And Bessie had some leaks, and I wanted to fix Bessie up. And I was fixing stuff that didn't totally make sense, But you guys do this all the time. You just don't realize it yet. Looking back, you'll realize you were doing some stuff that didn't make sense. But Bessie had some leaks, and I'm like, I'm going to reseal the intake. And so on the domestics, coolant goes through the intake, air, fuel, all that type of stuff on those older V8s. So I pulled the intake off, and the gaskets were old cork gaskets, and they were like 30 years old, and they were like petrified hard. I tried to scrape them, it didn't work, whatever. I went to the cookie disc. The cookie disc on this grinder, it totally cleaned it. Looked amazing. I was like, man, look at the job I did. And I put the gaskets on there, and it sealed great. And then I started getting like an intermittent red oil light, the genie lamp. I was like, man, why is my oil pressure down? I just resealed it. I resealed the intake. The oil right there is just splashing around. A leak right there was never going to cause an oil pressure issue. It's not in a pressurized oil galley. So it was sort of like, I don't know. I just didn't really know what I was doing. Well, the engine was getting kind of worse, and that engine was already burned a bunch of oil. It already had like a whole ton of miles on it. So the engine was already kind of beat. There I am trying to reseal an intake on an engine that's already kind of whooped. So it didn't really make a lot of sense anyway. But basically, I started getting more and more of those red oil lights coming on. The engine was burning a ton of oil. And then on break, people are like, hey, we're going to take a break. We got like a couple hours in between classes. And those were cool days. Okay. In a way, having a 2 hour break in between classes was pretty, that's when we go do these things like slide the cars around the lunch place, whatever. But this day, they're like, oh, let's go to this off-road trail. And I'm like, yeah, I'll bring Bessie as 4-wheel drive. I've been waiting for this moment. That's why I bought a 4-wheel drive. Let me see what my truck can do. So we went out there wheeling on the hill, and the hill was steep, and I was trying to run it up the hill, and I got kind of stuck, and it was a little low on oil already, and I knew it because it burned a lot of oil, and my red oil light was on, and it was like, I could hear it knocking, and I was kind of nervous, and I didn't really make it over the obstacle, and everybody heard the truck knocking. And I'm like, dude, what's up with your truck? And I'm sort of like, it's Bessie, don't make fun of me. But the thing was, it was pretty hammered, and then within probably a month, I was on my way to work one day, and I rounded the turn off the freeway, and I got on the road that goes to my dealer, and it was getting a ton of miles because school was far from home and school was far from work and stuff. I rounded that corner, and I just heard it. I just heard this noise. And you just hear like metal, and I'm like, oh no, this is it. She's seizing up on me. And so I knew if I slowed down, the engine was going to lock up. So instead, I just put my foot into it. You know what I mean? I was just in it to win it, punched it, ran a red light, got into the dealership with the thing knocking and screeching, and you could just tell it was just locked up. And then I'm like, okay, I got it in the parking spot. I'm going to shut it down. I shut it down, immediately try to restart, click, locked up. Done. I'm like, all right, that's it. Got the breaker bar, put on the crankshaft, went to turn it, locked up solid. It became a crank no start. It became a no crank no start. Starter wouldn't turn it, but I knew it wasn't the starter. The engine was locked up. Ended up taking it apart. This is what I found. In the oil pump pickup, a lot of this. There was all sorts of cookie and gasket material in there. My gasket prep substantially contributed to that engine locking up. And so you got some of you guys are struggling in the class. I feel you. Like I've been there firsthand. Not only have I read articles about how students are struggling who come into community college, like that was me. I already been there. So I feel for you when your focus is to fix the car, but I'm trying to get you something bigger where you know how to fix like customer cars so you can make money and have a bill. At that moment, I didn't have the money to fix my truck. I had the time. I didn't have the knowledge, but I had the time to fix it. So I didn't go with like, hey, get that engine coming. I got rides, I borrowed cars, and I asked favors, and I missed a little bit of class. And I was like, I'm going to rebuild the engine. So I pulled the engine out at work and took it all apart. That's how I found that it was mostly cookie disc material in there. But I also found it broke a skirt on the piston, scored the block up. The rings were all mangled. So that engine was junk. So right there, let me tell you real prices. Because I was an employee of the dealer, I could have got a rebuilt GM engine with a warranty for $1,300. And I said, I don't have $1,300. So instead, let me rebuild it. And my mentor sort of like, your block is all scored up from the broken skirt. You need a block. Like you might be able to save the crank, but your piston's broke. You basically need another engine. Why wouldn't you buy the one for $1,300? So like, cause I don't have 13. So instead I got a junkyard engine for like $300, right? The junkyard engine showed up. If you're going to do all this, it would make sense to freshen it up, right? I could have just slammed the junkyard engine and been done, but I also kind of wanted to learn, but I also thought, yeah, it'll be a cheap rebuild, right? I'll get rings and bearings and I'll be in gaskets. I'll be chilling. So when I go into the thing, the new engine needs bearings, but also needs cam bearings, and the cam is scored. So now I need it. My cam is bad. The new cam is bad. So I need a cam. If you're going to do a cam, you're going to do lifters. I hot tank everything. I scraped all the carbon. I scraped all that type of stuff. I ended up replacing everything that needs to be replaced. And I did get it done, and it was a really good experience, but it cost me about $1,200 because I had to send some parts out to have them honed. I had to send the block out to get cam bearings pressed in. Now I can press my own cam bearings, but at the time, nobody in the dealer knew how to do that type of work. So we sent it out. So I spent $100 less, and I spent like 3 weeks working on it. And I could have had the GM engine like in 3 days for $100 more and been back on the road. So it was a dumb thing I did. It was a dumb thing in several ways, all of which ended up kind of benefiting me. So I learned a lot about that type of work. And I also learned a lot about gasket prep, which is where we kind of started. When we prep the gaskets, you have to know what you're doing. So when we're scraping these, we're getting the FIPG out. When we're all done, we're cleaning this oil pan all the way out. And I've made several mistakes with gasket prep as well. One of them was I got it all prepped, and then when I went to put it on, oil had run across the surface on the block side. And I went to put it on, and that car came back with an oil leak. And when I took it back apart, it was like the FIPG was firm and well bonded everywhere except that one spot where the FIPG was just kind of like, it just slid around. Like it never set. So when we're doing our resealing, if you don't have all the oil off, that FIPG is never going to really bond. And that's what they call it like seal packing or 3-bond or something. So it needs to bond to both pieces of metal to make a good seal. Clean, all sorts of prepped. That's why I'll use this last. This is a bristle disc. This will take off the material, but it won't grind the aluminum. This would grind your aluminum away. You'd end up with a worse leak than you started. So this is a no. And it's messy. This fiber, you don't want that in the engine. I'd say ask me how I know, but you better know if you paid any kind of attention. So this is a good one. This would be like the final clean. Now it doesn't have to be polished, but there should not be any chunky pieces of sealer. It should be pretty clean. There's a demo on that, right? But when we're going ahead and resealing this, the quality of the rebuild also has to do with it not leaking afterwards. If you do a rebuild and the customer says they see a puddle in their garage, that's coming back. Just letting you know, right? So we go through, and by the way, there's multiple types. They have, for oil, they have different ones actually for coolant, by the way. And there's all sorts of different RTVs and FIPGs. Like I have some right here. We got gray type, we got black. Sometimes gray is more for like high tension things. Sometimes black is more oil resistant, but it'll call for something, and there will be an equivalent. And you should really use the one that it says. Additionally, I could give you 2 ways that I'm going to explain this. One is by the time you get everything prepped and you go to get this on and you brake clean it for the last time, right? You wipe it with your paper towel, whatever. There's no oil. That FIPG needs to already be applied with a specific bead, and then boom, straight on. No delay. Fast as you can. And get the bolts in and get the thing snug as fast as you can. Period. Then get it torqued to spec, and then you're good. If you don't get it on there that quick and oil runs down and runs across the surface, I'm going to tell you right now what's going to happen because I know firsthand. Right. So there's an urgency there, but having everything ready to go, having your bolts organized, all that type of stuff is going to make a big difference. And then getting it torqued to spec is good. And then they say, wait at least 2 hours per the Toyota handbook. Wait at least 2 hours before you add oil or, whatever the fluid is. Are you going to be fast enough to be able to beat 2 hours? Most of the time, really not. Have I seen people do it in less than that? Yeah, like when we were working on Kias, they had a lot of oil pans leaking, so we could pull an oil pan off, clean it up, put the FIPG on, blast the oil pan on, have it down on the ground in under 30 minutes with oil in it. And guess what? They sealed and they didn't come back. So the 2 hours is per the manual. Follow the manual. But I'm also telling you, we definitely were not waiting 2 hours and they weren't coming back until 1. And a guy who had the most experience, he should have been the foreman, but we didn't really have a foreman at that time, did one, and the guy came back. This guy was kind of weird. He would get under there and look for any sort of seepy dampness. Like he was not looking for drops or puddles. He was like pulling himself under the car, being like, it feels wet again. It looks a little bit dirty. So This one came back and this guy resealed it and he shipped it and it came back. And then he's like, well, that's weird. Maybe I messed it up. And he did the same thing, yanked it back off and resealed it and shipped it. And then the guy's like, hey, it's still leaking again. He said, okay, time to get more serious. So he told the guy, you need to drop it off. I'm going to do the work, but you can't have it back till tomorrow. And that's when we had to train the service advisor. You know, if the service manual says 2 hours, cool. But if you're having a problem, you might need to wait more. So he told him, have the guy drop it off like around noon. I'll reseal it, you know, in the after, that'll be the last car I work on. I'll reseal it, lower it down, leave it in the bay. I won't put oil in it until the next day. And he can have it like late morning. And so the customer resisted, but he agreed. He did it like that. I watched him. He lowered it and he left it there overnight and he came in the morning, put oil in it, started it. That fixed it. It never leaked again. So per the manual, they say 2 hours, but I don't know. There was this one time where he had to wait more like 20. And for some reason, it fixed it that time. I don't really know if it was coincidence. I don't have a good sample base to make a good statistical case, but I'm just saying it came back, and then he did it like that and it never came back. So I saw something there that day, right? So considering all that type of stuff. Now it talks about on some engines, you'll need to do valve train components. You may need to do adjustments. We did a demo on the adjustments the other day. When you're installing these camshafts, it's the same thing. We're going to pre-lube all these. They say engine oil, but I'd like to see the assembly lube because the assembly lube is going to hold up better. In sequence, possibly torque to yield, etc. On Toyota specifically, this what we call the camshaft subassembly, some people would call the cam towers. I would like to point out, you got the head on, you got the rocker arms on, you got the head bolts torqued, then the cam tower or the subassembly sits on there. But there's no gasket, that's all FIPG, and you got to have a really nice tight bead because those are known to leak. And if those do leak, you got to pull cams, you got to redo timing. It's a big job, right? So on our engine assembly after a rebuild, you got to keep this nice and tight, a nice clean bead, you know, nice. Okay, and then when we talk about timing, we talked about in unit 2, but in unit 3, we're gonna as well. So it's a little bit of review, but it's from the perspective of assembling. So when we go to do this, you're looking at all your bolts are torqued, your caps are torqued, your cams are in. Then it calls out to set your cams at a certain degree. And this is just approximate because ultimately when you bring your sprockets in like this has a hole right there that you guys can see. We're going to make sure that the pin right here, there's a knock pin, is going to end up in that hole. So if you put it in and the pin doesn't quite line up, you can move the sprocket a little bit, or you can even use a wrench on the cam and move the cam a little bit. So if it's approximate, it just means you have to move it less. That's not to say like, oh, I don't know if I'm at 55 or 56 degrees, fine. Just in the ballpark is great. Then you'll fine tune it with these. And when the knock pin locks in put the bolts in, torque the bolts to spec and you're good. But when you're doing that, you'll have to already have these timing chains lined up. So the cam to cam chain, like on this one, is this mark and this mark, but that varies engine to engine and sometimes bank to bank. So like right here, this is bank 1 and bank 2. I thought actually it had it. So these are single dots, but sometimes bank 2 has 2 dots, right? So I guess I don't actually have that shot. I thought I had one. So they can vary. It can be a single dot. It can be 2 dots. You're really going to follow service information closely. Oh, here it is. Single line for bank 1, double line for bank 2. It's like, what the heck? That's so they can use the same sprocket on both banks, but each bank needs to be timed a little bit different. So, okay, single line or 2 lines, follow service information very closely. Cool. Once those chain marks are set and you get them on, like onto the knock pins, you're good. Don't even worry about it again. Once those are set, you're good. Then you have to put the bigger chain on, and you can see this is going orange mark to this line. And then on the bottom, you're going to do orange mark to this dot on the crankshaft. And once you get those on, you're good. And you're going to probably have to do that with two banks. And now this is something I was trying to explain yesterday to a couple of people. On timing chains, you don't necessarily look for top dead center. You don't necessarily index this mark to a mark on the block anywhere. It's all about orange link to dot. It's all about orange link to the line. If those are good, you're done. You got to make sure they're all good. And then you could turn it over. And after 2 revolutions, those aren't going to line up anymore. And you're like, what the heck? This is crazy. It all comes down to these links are not going to come back into alignment for like 27 rotations or something. It's just statistically the way that there's so many links and only one mark. The links are landing on different teeth each time. This is a little hard to understand. I'm going to do my best. When you set it up, it's technically all about timing, right? But timing, if you think about it, you got your crankshaft turning, you got your camshafts turning. Where your crankshaft is in relation to your camshaft is timing. So the location is timing. You want the piston coming up with the valves closed, and then on exhaust, let's say intake, you want the valve to open at the right time, and then you want the piston to come down. The timing of that action sounds like time, but we control time with the chain. So in a way, the time is distance. What the heck? So as your crankshaft is turning, you want your camshaft to be turning, and we basically need a certain number of links between those two. We need those in the right spot, and then we need a certain number of links between them. If we had extra links between them, that would mean one of them is going to be late. If we had not enough links between them, that would mean one of them is going to be early. So essentially with timing chains, we're not necessarily worried about TDC. We're more worried about if we index this part of the crankshaft to this part of the camshaft, and there's a specific number of links between the two, it is in time, period. Even if you could set it a little over here, you could set a little over here, as long as the number of links are the same and they're to the correct marks on the cam and on the crank, you're good. Now you should understand why they have the orange links. The orange links is just to show you, hey, line up this mark to the crank and line up this mark to the cam. And if you do, you're good. Being chillin', right? And then once you do that, you have to understand something. On a timing chain engine, the timing chain tensioner is driven by engine oil. You don't have engine oil pressure until you have oil in it and you have the engine started, right? That's when it'll be tight. So when you go to put this together, if you want to turn it 27 times to double check your mark, you can. But as you're doing that, your oil pressure is going to be 0. Your timing chain tensioner is going to be deflated. You might jump the chains. It's going to clatter and make all sorts of noise. You could actually probably take a zip tie and tighten up the chain tensioner itself. So that way you can turn it 27 times, but I'm not going to turn it 27 times. If I know all my chains are lined up the way they're supposed to be, orange to line, yellow to yellow, and then orange to mark, I'm done. This thing is timed. I'm moving on. Kind of makes sense. So that's something a lot of people struggle with. But you got to make sure it's right. If you're a tooth off, you're redoing the job. So just make sure it's good. Your first time, call over someone with more experience and be like, will you check my timing marks? On your reassembly, ask me to check your timing marks. I want to give you some critical feedback. But on a timing belt, get your marks all set and then turn it twice, and then I'll check them. But on a timing chain, let me check them just as you said it. Because once you turn it, it's hard to get those links to all come back into alignment again. Okay, so kind of tricky thing. That's what this is showing, bringing the chains up. You can turn the cam with the wrench to get the sprockets to pop onto the knock pin, right? And then again, speaking of gasket prep, the timing cover is a beast. It's calling for specific thicknesses. We covered a little bit, but a continuous line of 3 to 4 millimeters on all this. A dashed line is going to be 6.4 millimeters. That's going to be a thicker bead of the FIPG. It also even calls for FIPG on these points where the center of the cover is. It's not just FIPG all along the edge. You're actually calling for it on these points too. So there's a lot to it. You're going to have to be pretty fast at that. By the time you pull your FIPG off that top edge, you better have that engine already clean, ready to go. You might give it one quick shot of brake clean, one wipe, and then get that cover on there like now. And to make it worse, when you do, this is the oil pump, and there's actual drive lugs on there, and you have to have the oil pump kind of in a certain position to go on to the crankshaft. So you may want to dry test fit this a few times, make sure everything is perfect, and then do the FIPG and then get on there. A lot of MDT, a lot of diagnostic people, a lot of people who can pass their ASE, a lot of people who are great students. They can study, they'll do every chapter, they'll be on Canvas doing all their work. They will struggle with something like this. This just, it's urgent. This is more mechanical aptitude. Like a lot of people talk trash on people who can't diagnose, and rightfully so. But there's a lot of people who can diagnose who can't do this timing cover and have it not leak. I'm just letting you know. This, especially the 3UR, that thing's a beast. Thing is no joke. Okay, for sure. And then there's all these different bolts to make it as complicated as possible. Like I mentioned, maybe you want to make a piece of cardboard, maybe you want to poke the bolts in the hole. This job is an animal. It's gonna be tough, and it's gonna be tough in the car. It's tough. It's tough with the engine out of the car. It's really tough with the engine in the car. Just the way it is. Now, when we go to start it, we're gonna have used that assembly lube, so we shouldn't need a ton of oil system, lubrication system priming. But the more we prime it, the less of a dry start we're gonna get, the better, right? We're trying to make our rebuild last. So, for example, a lot of this type of stuff might have sealant on the plugs and etc. We could pre-lube the oil filter. That's one thing you can do. You can actually fill this oil filter with oil, because when you start it, that oil pump's got to fill the oil filter before it builds oil pressure. So if you fill the oil filter first, that does help. That's a nice little thing that you can do. And then in some cases, there's a method. Like in this case, we're hooking up a drill to the oil pump drive, and we can actually spin it with a drill. That'll run the oil pump, and it'll actually build oil pressure. That would be great. That would be amazing. On the LS, it doesn't work that way. You actually have to use like a pressurized pump to one of the cooler ports, and you can pressurize it. A lot of engines don't have a real good mechanism to do that. Toyota, for example, is driven by the crankshaft. You'd have to spin the crankshaft really fast to pre-lube it, in which case that's kind of the same as starting it. So we don't really do the pre-lube on a lot of Toyotas. We just make sure we're really good about our assembly lube to make sure it doesn't have a dry start, right? And so this is an example of pre-lube where you're actually turning the crankshaft, or in this case, we're driving the crankshaft rear main, or, there's a couple things you can do. This one is actually driving the rear main, now that I look again. But they do have some where we're turning the engine to get everything pre-lubed too. So do the last final seals, fill the crankcase with the correct amount of oil. Now, right here, there's supposed to be an insert for break-in, and I'd like to clarify some things. You guys work on cars that are sold brand new. Does anybody bring their car back in for a 500-mile break-in service? That's not a thing. On new cars, it's not a thing. On new cars, when they machine the block, everything is clean. They run a diamond-tipped brush hone through the cylinders. That gets rid of all the metal. That engine is essentially pre-broken in on assembly. So the car comes with oil, it comes with regular oil, and we do the oil change when the light comes on, 5,000 miles, 7,500 miles, maybe 10,000. Has anyone ever had a customer come back in 500 miles and say they need to change their break-in engine oil? Anybody?
Some cars call for it like every 1,200 or 600 something.
Give me a car and I'll fact check that.
The GR Corolla and the GR Supra.
Okay, so the GR Corolla calls for that according to who, and can you cite your source?
I see that on my on the owner's manual online on the Toyota website.
Okay, if you can find it on your Toyota owner's manual, I'm good with that. However, the reason I bring this up is I've also been on the internet too, and especially a lot of forums, and there are parrots on parrots on parrots who would say, you need to bring your car back for your break-in oil. You need the break-in oil. You need to get your break-in oil out. Maybe you'll find an exception, but I'm gonna say 95% of the time there's no break-in oil. Break-in oil is an actual product. They sell break-in oil. It's just basically oil that's supposed to be used for like 500 miles. Sometimes it has extra zinc. Sometimes it's actually worse oil. It's crappy oil that's only got to last 500 miles. So like if you do an overhaul that's not from the factory with the diamond tip brushes and all that type of stuff, you would say, yeah, come back in 500 miles, change the oil. That's your break-in right there. That was true. But from the factory, 95% of the time, they put regular oil in there and your oil light doesn't come on until the regular interval. And if you look on the service manual, it just calls for regular service. So the first oil change is no different than any other oil change 99% of the time. You guys know because you have Toyota Care, the first oil change is not even an oil change. It's a 5K, right? A 5K is a tire rotation. They don't even change the oil at the 5K. They wait until the 10 to do the first oil change. So separating facts from myths is something that's pretty important. So that's not to say there's not some exception. Nate may be right about a GR Corolla. It may call for the oil change at 800 to 1200 miles, but I don't care at all what anybody on the forum says at all, not even slightly. That's not relevant for us. That would never be something that could be brought into court unless there's some sort of professional witness. And they'll be like, you're a professional witness. Why? Well, I own the car and I was on the forum. Like, you're out. If somebody's done studies, maybe they work for the oil company and they're like a, lubrication systems engineer, then maybe I would consider what they're saying superseding what the manufacturer service information says, but that's not realistic to happen. Makes sense? So whatever the service manual says is what goes. That's the gospel truth right there. So that's the matter of fact. Now, if you say on your own, I bought my dream GR Corolla and I personally want to change my oil at 600, no issue, by all means, 100%. But Toyota, if Toyota doesn't call for it, we don't want to make it so Toyota says that, because if Toyota didn't say that, they didn't say that, right? So as far as break-ins go, generally speaking, there's no break-ins period from the factory. However,
I don't know. Sorry.
well, I'll come back to it, Nate, because I want to get the facts straight. But if you rebuild an engine and we're doing the hone, right? Like you guys saw the hone the other day, they're doing stones and stuff and there's metal and that metal is kind of going down the block. After a rebuild, it's very common that there is a break-in period and we follow the break-in procedures. It talks about pre-priming the oil, starting it, idling it for a certain amount of time, doing some light acceleration, doing some deceleration. That procedure will vary depending on the machine shop, but also depending on who manufactures the piston rings, also depending on, depending on exactly where it was built with exactly what machines. Make sense? So that's something that the overhaul company or person would specify, and that can vary. Okay, so we're pretty clear on that. Everybody kind of clear-ish on that.
Yeah, I was gonna ask a question about that because I know there's the oil, like people say like the oil change break in, but they also say like the driving procedures too, for a new
Yes.
car to break in stuff.
Yeah. So let's because we're interested in total complete truth, this is what we can do. 1.tis.toyota. Let me pull this over and let's just get it straight. Because if you jump on the forum, I don't know. I think honestly it has to do a lot with like people's psychiatry in their mind. Is like a lot of times I think they want to be important and they have to have something to say and they feel good having the last say in the thing. But if you want to search and understand like the facts and the truth, you got to disregard opinions and you got to just go right for the source. So let's say we wanted to know, we could jump into TIS. It actually may be in the service manual. It may be in the owner's manual. So we might have to jump around a bit. Let's just say it's a Corolla. Let's see. You know what? I don't know if it has, there it is. GR Corolla. Let's go with a 24. Let's go, I might have to jump into, let me think of, where is this? It might be under reference information. Yeah, I think it's gonna be under reference information. Yes. Okay, Toyota yes, model GR. Okay, year. Oh, it doesn't care. How about? Why is it mad at me? Why are you mad? Okay. Let's go with oil. Okay. Warranty and maintenance, owner's manual, owner's manual. We could probably just shoot the owner's manual right away. We can most likely do keyword search. Okay. And so in this particular case, I don't have the facts. I do have some statistics on most cars, but I would never say, no, it doesn't need it unless I've looked it up, which is part of the lesson. Okay. So if you look it up, then you know. If you don't look it up, you're really just guessing. Talks a lot about gauges and stuff. A lot about the gauges. Okay.
Try Control F.
Yeah, I'm running Control F right now, but the problem is oil came up 164 times. We could, I'm also thinking about doing break-in. Yeah, because that's going to be just a lot. Break dash in. That didn't spell right. Let's see. Okay, break-in tips, page 121. Let's go for that. Well, it says 121. Yeah, that should work. Okay, here we go. Talks about breaking your Toyota to extend the life of your Toyota vehicle, observing the following precautions recommended for the first 186 miles, avoid sudden stops. This is really more talking about brakes. For the first 621 miles, do not drive at extremely high speeds, avoid sudden acceleration, do not drive continuously in low gears, do not drive at a constant speed for extended periods. It also does talk about idling time before engine stop to prevent damage to the turbocharger, allow the engine to idle immediately after high-speed driving or hill climbing. That makes sense. It gives you some specifics about letting it idle. We could continue to see if it shows anything about oil here. All right, and we could also lubrication condition. Yeah, I mean, this is all pretty generic things. We could also look at the maintenance schedule. This is where you get information about whether it can be towed, by the way. So regarding engine break-in, I mean, it did say, don't be running at high speeds for the first whatever miles it is. So the manufacturer, this engine is Toyota, they're giving us the break-in criteria. So that was good. Let's do an oil change because it'll probably call out the first oil. No, it didn't find oil change. It might be oil replacement. It might be just engine oil. All right, let's see if we just use this. No, it's not really talking much about that, light bulbs, etc. So let's do, I'm going to say interval because a lot of times they'll say maintenance interval. So far, I haven't seen anything calling for.
Didn't it say the page number right there when right next to the engine oil? It said 3 something, no?
It did, but it didn't say anything about break. I mean, it's talking about scheduled maintenance. I'm looking actually right now for the maintenance schedule, but did it say where it is? Okay, here you go. Just checking these, but it's not really talking about mileage yet. The mileage is going to be somewhere in here, clearly. Okay, so let me search interval a little more. Okay. Talks about oil a little bit. When to check it. Okay, refer to separate scheduled maintenance or the owner's manual supplement. Okay, so you know what that means? they're saying, hey, there's a separate manual, so we might have to actually find a separate manual. The problem is when I put on the second screen, it's hard for me to X out. Let's say, quick reference, no, there should be a supplemental warranty and maintenance guide. Let's go with the 24. So Nate, I'm very careful to say it doesn't need the break-in, but so far we haven't found it. Maybe we're about to find it in here. Welcome to the Toyota family. You've been welcomed. How do you feel? Hopefully you're doing good. Your responsibilities, operation and maintenance, I'm going to say probably 30. Let's get to 30, right? Because it's going to tell you your responsibility. It tells you all about the warranty. Okay, we're only at 16. We got a little ways to go. Yeah, this is overall, this is all standard stuff. You have to maintain it to maintain your warranty, etc. That's normal. It gives you a little explanation on why scheduled maintenance is so important. See, maintenance log charts, here you go. Toyota recommends obtaining scheduled maintenance for your vehicle every 5,000 miles. For example, if you drive 5,000 miles, you should do it at 5,000. Don't wait until 6 months. But if you, in 6 months, you haven't done 5,000, do it at 6 months. Okay. That's also generic. I don't think any of this has been specific to the GR. Okay. Every 1,250 miles, inspect the engine air filter. Every 2,500 miles, look at this. Additional. Oh,
I have been doing that.
if you're driving on dirt roads and dusty roads, you could do your engine oil filter, oil and oil filter if you're under special operating conditions. But so far, I don't see any break-in call out, right? 5,000, you could do an additive, you could check X, Y, and Z. It does say replace the engine oil and filter at 5K on this particular one. So actually, it looks like the interval is going to be tighter on the GR because this is GR specific. This is, you see it right there, 24 GR Corolla specifically, but without wasting a ton of time. Nate, you got access. You can go through this with a fine-tooth comb and report back if I'm wrong, because I didn't feel like I could spend the exact amount of time that I didn't want to. Now look at this, refer to owner's manual. Yeah, so it's referring us to this or to that.
I feel like it
don't
would
see
have
where
said
it
it
says.
already.
What'd you say?
I said I feel like it would have said it already. So it's
I
probably
think-
just different online.
Exactly. So my goal here is not to be right. My goal here is to help lead you guys to the truth where if you want the matter of fact, I promise you, you don't want everybody's opinion because everybody's going to tell you what they think, what they heard, what they knew, what their friends said, what their friend's friend said, etc. Ultimately, the business we're in, you're going to be the certified professional. So you're going to be held accountable. If one of the guys on the forum says you do or you don't or whatever, and they get hauled into court, they're going to be like, well, what do you do for a living? And they're going to say, well, I'm an accountant, but in my spare time, I go on the GR Corolla forum, I tell people, stuff. They're not going to really be in trouble. Whereas for you guys are going to be certified, you're going to be professionals. If anything goes sideways and you have to testify, you can't claim like, I don't know, but see, they can and you can't. So what I always wanted you to do is to be able to pull you back to the fact. And that's true with break-in, but that's also true with the whole engine discussion. If somebody looks at an engine, they're going to be like, oh yeah, that's okay. Like, what do you mean that's okay? Did we measure it with the micrometer? Did we evaluate it against the manufacturer specs? See, so that's how I want to rewrite your brain to just function. You don't have to know everything. What you have to be able to do is obtain the facts as shown, like something like this, or as shown in the service manual, and then be able to apply those criteria to your particular measurement. And that's really, honestly, that's what society needs, first off. And secondly, that's what Toyota wants. That's your job. Your job is to really follow the procedures, and Toyota's giving you the procedures. Toyota gives you what you need to be successful. But if you're influenced by, people who are going to say, oh, no, you got to do it like this, you got to do it like that. Just know you can't go into a court ruling. You can't write on your story for warranty that you read it on the forum or that somebody who's had 3GR Corollas told you. Like, none of that holds up. Okay. So we're just right on the facts, right dialed in. And basically, we're pretty much there, by the way. This is basically the end of the PowerPoint is just saying when you're ready to install, you're going to do your final sensors. You put your intake manifold on, your exhaust manifold on, get them sealed up. And then with that, your engine's ready to be installed and ready to be broken in. Cool. You guys feel pretty good? And I'm gonna go ahead and end the recording. My computer will function for me.